They are the fastest, the largest, and the most dangerous in the world.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air, all of them are ultimate vehicles. In this episode, a gigantic swimming parking lot, the world's largest car carrier. Once, this was the fastest and most expensive private yacht at sea. 90 years later, it still holds records. Also in this episode, the largest container ship on Earth on its maiden voyage. Some call it the Concorde of the Seas. This catamaran holds the title of fastest commercial ship in the world. And finally, a state-of-the-art submarine on a secret mission, a nearly silent spy. It is the largest container ship in the world, the OOCL Hong Kong, a gigantic high-tech freighter made for international trade. One of the most fascinating, but also one of the most dangerous workplaces afloat.
At sea, no one can help you.
The freighter's risky mission, a delivery to the other side of the world, in only about 35 days, and each hour of delay costs a fortune. At 400 meters, the OOCL Hong Kong is longer than an aircraft carrier. She can hold more than 21,413 standard containers, more than any other container ship in the world. Koche, a seaport in South Korea. Here begins the maiden voyage, a risky ordeal for the swimming giant. It is designed for a carrying capacity of 191,000 tons. But so far, that is pure theory. Now we'll see if the ship can actually carry the enormous cargo and transport it in the short time frame. For Captain Lam Chung Fat, this voyage is the highlight of his career and the ultimate test of his abilities.
I'm glad they called me because this is a very challenging thing to bring out a new ship like this. And everything is new on the ship and I have to set up the whole ship. So it's actually quite challenging.
Massive responsibility also weighs on another crew member. Deep in the ship's belly, Levi Chi makes sure that the ship will reach its objective in the time allowed. The chief engineer operates one of the largest engines in the world. But that Levi Chi ended up here was one big misunderstanding.
When I was young, I saw a movie called Love Boat. I said, wow, this man very happy with all the girls drinking and bar, not working. So I decided to be a seaman. And then I found out, container ship, no, you don't have all the bar, beer, party every day.
Instead, reality strikes. An extremely dangerous workplace, responsibility for a 2,200-ton engine, and enormous time pressure. The transport business is highly competitive. It is dominated by the shipping company that can transport the most containers for the lowest price and in the shortest time. The OOCL Hong Kong may be able to load more containers than any other ship, but on its maiden voyage, the mega freighter must prove that it can stick to the strict timetable. Only then will it be profitable. In Shanghai, the world's largest container port, the ship loads its first cargo ever. It can transport a total of 191,000 tons, corresponding to the weight of 336 A380 airplanes. Now we'll see how the ship fares under such a gigantic load. Till now, there has only ever been a computer simulation. For the crew, the coming days at sea will become their greatest challenge. The same time in South Korea, at Samsung Heavy Industries in Koche. It is the most sought-after shipyard in the world and as big as a small town. Over 35,000 people build 30 swimming giants each year, including 6 of the new premium class of ships, at a price tag of $950 million US. For engineers and shipbuilders in particular, the new mega container ships pose a tremendous challenge: more power with lower fuel consumption. All with one goal in mind: the lowest transport price per container. One man oversaw the entire process of building the new high-tech ship. The project leader, Kim Yong-ha.
This ship is full of intelligent technology, which makes it environmentally friendly and saves energy. For me, it's not only a huge cargo ship, but the best in the world.
The OOCL Hong Kong is not substantially longer or wider than other container ships. Nevertheless, it can transport many more containers. In comparison to other megaships of the same size, the OOCL Hong Kong carries an additional story of containers. The secret lies in the ship's design. Its structure contains less steel than that of all other container ships, and so, the lower the tar weight, the more space for cargo. Precisely this relationship of tar weight to gross weight makes it the most efficient container ship in the world.
A battle of giants reigns in the cargo industry. The cargo could also be divided over 2 ships. So, with a load of 21,000 containers, one ship could take 13,000 and another one 8,000. Some shipping companies do it like that. We can transport everything with one ship. We only need half the crew. We save ferry costs and time. So, this ship lets a transport company earn higher profits.
But how will the system fare on the high seas? The shipping company's new flagship, the OOCL Hong Kong, is loaded and on the way to Singapore, its first destination port. The crew must check and secure the cargo many times a day, especially the hazardous material and freezer containers. What looks like a smooth ride above water requires maximum concentration below. The engine room, a cathedral of engineering. The engine block is 9 stories high. Its tremendous power shakes the whole room, comparable to a small earthquake. The room's temperature is between 40 and 50 degrees Celsius. The metal is so hot that it can cause severe burns. Every day, Li Wai-chi points out the dangers of the job to his team.
Safety is the top priority. You got all your safety gears ready, is it? All your safety helmet, chip band, and everything is ready, is it? And in good order. And in engine room, when you sit here, no problem. When you go out, you must put the sleeve down because everything is hot. And don't touch any engine. No question? 有没有问题? 有没有问题? 没有问题? Okay, move. Excellent.
Routine or the slightest carelessness, both can be fatal.
At sea, no one can help you, except, I think of someone. God may help you, but sometimes he forget.
Chief Engineer Li Wai-chi keeps an eye on one part of the engine in particular, the propeller, and the propeller shaft connected to it. The problem, with a heavy cargo, the shaft is very sensitive to movements. Sharp changes in course, such as tight turns, can cause the shaft to rub against its casing, and in the worst case, start a fire. If the temperature exceeds a critical point, the chief engineer tells the captain to adjust the course, and thus ease the pressure on the shaft. But today, everything is running smoothly, and the ship maintains its course. Should the shaft ever spark a fire, this would be an enormous danger. In no time, the fire could spread to the entire ship. For this eventuality, nearly 800 CO2 bottles are on board. In an emergency, Li Wai-chi could flood the engine room from here with carbon dioxide and thus extinguish the fire.
I never used this before. It's luck. I think not many seamen have to use this system because this is the CO2 for the engine room. If we're going to put the CO2 to put out the fire, that's the last resort.
The bulk of the distance to the port of Singapore lies behind the crew. Li Wai-chi has performed his task. He has kept one of the world's largest and most powerful diesel engines under control. The first test run of the maiden voyage was a success. In the future, the OOCL Hong Kong will shuttle permanently between Asia and Europe. From China over Singapore through the Suez Canal, all the way to England, the Netherlands, Poland and Germany. A course to the other end of the world in a mere 35 days. Captain Lam Chung Fat will stay with the flagship. A total of 6 of these giants link the world's markets, delivering fresh supplies for our consumption. Other giants of the seas operate more covertly. One of our ultimate vehicles, the world's most modern submarine. And a ferry with an aircraft engine at heart, faster than every other commercial vessel. Gigantic container ships have become the symbol of the globalized world. But they are not the only mega freighters on the 7 seas. The Höegh Traveller, the world's largest car carrier. If all the automobiles that fit in its belly were lined up end to end, they would stretch for 40 kilometers, twice as long as Manhattan. Today's goal, loading the ship in 12 hours. The Traveller's maiden voyage was in September 2016. There is room for up to 8,500 vehicles on its 14 decks, even for heavyweights of up to 375 tons. Germany, Bremerhaven. Germany, the world's leading exporter, ships 3.5 million new vehicles a year from here. Car carriers transport the cars around the globe. The largest, the Traveller, and its structurally identical sister ships. 6 a.m. Port Captain Kjell Arne Berger is responsible for loading up to 8,500 vehicles. He discusses final changes. All the cars must go to the right place. The eye of the needle is the ship's ramp.
The worst thing that can happen is that we have a breakdown with a big machine on the ramp, as you see out here, because then traffic in and out is stopping.
Once the ramp has been crossed, the cars are distributed over a cargo area of 71,400 square meters, the equivalent of 10 soccer fields. The Traveller can accommodate 30% more vehicles than an average car carrier. But it's not only designed for cars, but also for heavy-duty transporters. The ship's ramp can bear an entire 375 tons. And the doorway, at 12 meters wide, can handle the very biggest monster vehicles. The same goes for the decks. 5 are height adjustable. Thus, there is space for vehicles up to 6.5 meters high. With a total of over 100,000 parking spaces, it is Europe's largest parking lot. Cars, pickup trucks, and heavy-duty transporters, all are waiting to be shipped. A scanner system registers all the automobiles that arrive in Bremerhaven. Shunt drivers collect the new vehicles from the lots and drive them on deck. Guides coordinate the parking. An important detail, the cars must be positioned so that the ship's balance is maintained. Parking is not the end of the job. Securing straps keep the vehicles from colliding with one another during storms on the open sea. Along its route, the car freighter constantly picks up new vehicles and unloads others. A logistical masterpiece. Time and again, vehicles must be relocated within the ship to keep the balance right. The adjustable ramps are an enormous help, an advantage of the modern ship.
It's much more flexible than older ones, so as far as you get to know all its varieties, that you can lift the panels and liftable decks, it's more easy.
This completely new class of ship was designed and built in the Chinese port city of Xiamen. Engineer Jan Rune Merkin is the head of new building at the shipping company Höegh Autoliners. His assignment with the Traveller: to construct the most economical and simultaneously the most ecologically friendly car carrier in the world. Size makes both possible.
We had to keep the vessel within a certain limit of length, which was less than 200 meters. And within those 200 meters, this 8,500 unit was the maximum that we could get out of that.
A berth is 200 meters long. For every additional meter, a second berth must be paid for. Yet the true engineering challenge was keeping the deck heights adjustable.
Liftable decks is a challenge because in particular for this ship, which have 5 of them, and one on top of the other.
The great challenge: the decks must be light enough to be lifted. At the same time, they must also be sturdy enough to support large, heavyweight vehicles. After only 2.5 years, the first ship of the new class left the shipyard, sent off with a loud blast.
You know, it's a great moment when a ship is completed and when the ship is leaving the shipyard. A usual procedure is that when they leave, they will use the air horn. And it's just like the air horn is saying goodbye, thank you, now I'm on my own.
Loading in Bremerhaven. The ramp can even take monsters like this vehicle. So big that trucks look like toy cars in comparison. A vehicle of this kind can weigh as much as 100 cars. But even this colossus is held only by securing straps. All in all, the ship transports vehicles with a total weight of up to 20,500 tons. Tractors, buses, trucks, diggers, and other construction vehicles fit into the ship's belly. Late afternoon, shortly before the end of the shift, an especially tall excavator must be loaded. It clears the stern opening easily. But then comes the interior ramp. Things get tight. And then the operation team notices that it will not fit through.
The deck was high enough for the unit, but the units are higher than in the bookings.
An incorrectly recorded height, and now time is running. The port captain and his team must first tow the excavator away and then find a new parking space for it.
We can easily go into overtime if this happens and stay too long.
Kjell Arne Berger rolls up his sleeves. The solution: the excavator will go on the main deck. That way there is no interior ramp to cause problems. The main deck is still too low, but thanks to the adjustable levels, 4 meters 80 centimeters quickly becomes 6.5 meters. Thus, there is room for the excavator too. After nearly 12 hours of work, the job is done. All the vehicles are on board. The port captain receives a final manifest. His job done for today.
See you next time. Good job. No, I'm just happy that we finished and everything went quite smooth. We had some small problems with a unit that was a little bit too high, but totally over 600 units loaded and everything went smooth.
And tomorrow, this gigantic car carrier will already arrive at the next port. Other than size, it is above all speed that excites engineers. The fastest commercial ship in the world is this high-speed catamaran, a true ultimate vehicle. Few freighters make it to 30 years. Only cruise ships are broken up sooner. The oldest cruise ship in the world, however, is already almost a century old. She is one of the last of her kind, and despite her age, still one of the biggest and fastest sailing ships of her class.
This ship, it is like a living creature. Sometimes she is capricious, you know, like all ladies.
Commissioned by an American millionaire, the Sea Cloud was at the time the most expensive private yacht in the world. Today, she is a luxury cruise ship with capacity for 60 passengers. In 1931, the Sea Cloud was launched under the name Hussar, around 110 meters long, outfitted with 30 sails. Then as now, she is absolutely uncomparable. The Caribbean, Trinidad-Tobago, Man-O-War Bay. The Sea Cloud lies at anchor in the bay of the tropical island. Today's destination, the island of Grenada, about 100 kilometers away. The Russian Vladimir Pushkarev has guided the ship across the seven seas since 2009, and with 1931 technology.
We don't have a pitch control of propellers. We use an old telegraph, old way of maneuvering. So, kind of classic, old school.
And what's more, the entire hull and a large part of the superstructure are still original to the 1930s. Sometimes the technology goes haywire, like the capstan right now.
Modern ships, they have hydraulic winches, they have hydraulic brakes, and you know, all push-button controls over there. Over here, you could see in all, you know, brutal way using muscles.
After some loving maintenance, the winch works again, and the Sea Cloud can finally set off.
Okay, anchor home.
Although the Sea Cloud is a sailing ship, it uses engine power to reach the open sea. The winds in the bay are simply too weak.
300, please.
300. 2 ahead slow.
The signal goes from the bridge right to the engine room. Here the steerage is also the same as nearly 90 years ago. Only the two 772 kilowatt diesel engines are new. They can bring the Sea Cloud to a speed of up to 10.5 knots. The Sea Cloud is an early forerunner of today's hybrid vessels. In 1931, it already had 4 diesel generators on board. They produced the electricity that, through 2 electric engines, powered the 2 propellers. The rigging of the 4 masts was also designed for speed. To achieve a low center of gravity and stability, the masts and rig are made of steel below and wood above. The combination of modern engine drive and sails made the Sea Cloud the fastest ship of its day. Today, the crew consists of about 60 people, the same as the number of guests. 4 to set 30 sails, plenty of manpower is needed.
We are bracing opposite tack. Call crew, stand by.
Roger, opposite bracing.
Everything here is done with pure muscle power. The only small bit of help comes from electric winches, which help to turn the yards into the wind. It takes more than an hour to set the sails on the 4 masts. They give the Sea Cloud an impressive total of 3,000 square meters of sail area. The sails must be changed every 5 to 7 years. Gdansk, Poland, is home to one of the largest sail makers in Europe. The workers here make the sails for the Sea Cloud by hand, as large as 200 square meters and weighing up to 100 kilograms. Captain Adam Pascho was previously the Sea Cloud's first officer, and today he is responsible for its maintenance. No one knows the ship as well as he.
In the 1930s, this was the biggest, the best yacht, private yacht you can build. Everything what you can get on the market in those days was placed on the yacht. The best whatever you can build in the world.
No wonder. Its owners, the stockbroker Edward F. Hutton and his wife Marjorie Merriweather Post, were among the richest Americans of the period. From 1942 to 1944, the United States Navy used the ship as a Coast Guard cutter. For this purpose, the masts and luxury furniture were removed and put in storage. After the war, the ship was returned to its original state. In the following years, it often changed owners and names until, at the end of the 1970s, it was ultimately brought to Germany and converted into a cruise ship. In addition to new sails, a great deal of other restoration was necessary. It was a difficult balancing act, as Captain Adam Pascho knows.
The biggest challenge is to keep her character, to do repairs but not to change the ship, and to get the material for the ship, and of course to do restoration of the luxus area.
The 10 original cabins, such as this one, which belonged to the millionaire's wife, have been preserved intact. Where cruise ship guests stay today, heads of state, Hollywood stars and captains of industry slept nearly 90 years ago.
The future of the Sea Cloud is quite clear. I would say as long as we can keep her safety standard on the highest level, and as long as we can keep her maintained to provide this safety environment for the passengers, for the crew, that she can be seaworthy, that long she's supposed to sail.
Meanwhile, in the Caribbean, the Sea Cloud has nearly reached her destination. But the real challenge is about to come.
We have to go inside of the old harbor, St. George's Old Harbor. There are shallows all over here, 5 meters, 6 meters shallow waters. This is the size of the ship. That's how we will go, and then approach, then stop, then turn. Yeah, no, of course, the challenge, do not hit the dock.
To this end, the crew must gather the sails. Only then can the Sea Cloud be maneuvered into the narrow harbor. The harbor pilot comes aboard to help. For the Sea Cloud is actually much too big for the small harbor. The channel is only a bit wider than the ship. The mood is tense. A few meters too far to the right or left, and the Sea Cloud will run aground in the shallow harbor.
All stop! 2 back slow!
After nearly an hour, the job is done. Vladimir Pushkarev is relieved.
It's a nice ship. It's really something. I feel myself privileged to sail on this ship and to be a captain. It's a dream.
And in only a few hours, the Sea Cloud will depart for its next destination. Similar to a sailing ship, this ultimate vehicle also slides by almost silently. Later in this episode, the most modern submarine in the world. From the erstwhile fastest sailing ship in the world to the current water speed record holder. The next spectacular ship is a true pioneer of modern seafaring. Aircraft turbines turn this large catamaran into a true speedboat.
My job is unique. Perhaps it's like that of a Formula One driver.
We're talking about the fastest commercial passenger ship in the world, the HSC Francisco. She accommodates 150 cars and just over 1,000 passengers, and still reaches record speeds. That means 58 knots, or 107 kilometers per hour. Only small speedboats are faster. Argentina, Buenos Aires. Puerto Madero, Argentina's biggest port, indeed one of the biggest in Latin America, and home to the world's fastest passenger ship, the HSC Francisco. The hull, a 100-meter-long catamaran constructed of light aluminium. The ship is a masterpiece combining all the tested technologies of speedboat building. 2 aircraft turbines supply enormous power. Fully loaded, the ship can still reach a high speed of 52 knots. A total of 3 decks provide space for engines, cargo, passengers, and crew. Every day, the ferry shuttles twice between Buenos Aires in Argentina and Montevideo in Uruguay. The first ship leaves the Argentine capital at daybreak. Boarding, loading, and engine check take place simultaneously in only 1 hour. The most important man on board, Captain Nico Strasser. He has been guiding the ferry between the Latin American capitals for 3 years. His job is more than mere work to him.
I feel very good. Being captain is a great satisfaction. This ship's technology is different from others. It's brand new.
The crew carries out the engine check with the onboard computer. Each tiny sensor can be monitored and controlled from here.
The ship is technologically complex, especially the gas turbine drive. Small problems always crop up.
The trickiest moment, refueling. The HSC Francisco's main fuel is liquefied natural gas. She is the first ferry in the world with natural gas propulsion. While the crew refuels, no electronic devices may be nearby. There is a great danger of explosion. 10 minutes before the high-speed ferry departs, the captain gives the signal to start the engines. The turbines need this long to reach their full power. The crossing to Montevideo, Uruguay, 190 kilometers away, lasts 2 hours and 15 minutes. Across from the HSC Francisco's berth, a fleet of maintenance engineers works. Among them, Gerardo Babini. He was part of the building team in Tasmania and knows the ship better than just about anyone.
The secret of this ship is the relationship between its power and weight. The Francisco has 2 22-megawatt turbines, and that's how the ship reaches such high speed. So, the turbines have an advantage. They have a lot of power for such a light vessel. Like with airplanes. They are aircraft turbines, after all.
The ferry's enormous propulsion power comes from 2 modified gas turbines, which also power much larger ships like the Queen Mary 2. Each of the catamaran's hulls has an engine and machine room. The special feature, the turbines were developed to burn liquefied natural gas and marine diesel. However, liquefied natural gas is the ship's chief fuel. The turbines, which each generate 22 megawatts of power, drive an impeller transmission. It, in turn, creates a water stream and drives the water jets. The HSC Francisco, a tour de force of shipbuilding. The greatest challenge for the engineers was not during construction, however.
Getting from Tasmania to Rio de la Plata was so hard. The fuel tank capacity was too small for the Pacific crossing. So, we stowed 8 additional balloons with 25,000 liters of diesel in the cargo hold. That's how we made it across the Pacific. Very difficult.
Difficult because the catamaran is built for shallow water with few waves, not for a journey across the 7 seas. Meanwhile, the turbines have warmed up. The voyage from Argentina to Uruguay along the La Plata River can begin. The turbines bring the ship to a speed of over 50 knots, gulping down a hefty amount of fuel in the process. But since the ship is powered by natural gas, the high-speed catamaran is also one of the world's most ecologically friendly ferry.
The biggest risks are launch and landfall, like in an airplane.
The passenger ship is named for the Argentine Pope Francis. Guests travel comfortably in 3 different classes. And they have the opportunity to shop in the largest duty-free store ever built on a ferry. Tickets for the trip to Montevideo start at $100. The passenger ship takes a good 2 hours to travel to Montevideo.
Hello, this is Francisco. We're arriving in the harbor.
Captain Nico Strasser turns off the autopilot and guides the ferry manually into the harbor, using only 5% of the ship's total power. The maneuver requires the entire crew's absolute concentration. The smallest steering error can result in a harrowing accident.
The greatest danger is ramming the harbor wall. That's why we go at the lowest speed possible. Captains must complete a 3-month training course here to master the landing maneuver. Ultimately, experience brings a sense of security.
The ship did ram the wall in Montevideo once. That totally destroyed the catamaran's front blade. Today, the captain guides the ship safely into the harbor.
Very well. That's finished. Sometimes it's like very stressful when it's really windy and dangerous, and then you're like, okay, we do it. But no, normally it's just routine.
In Montevideo, a smooth transfer takes place. While the passengers and Captain Nico Strasser leave the ship, the next crew prepares for the return journey with a high-speed catamaran. With a jet engine, one hardly goes unnoticed. Our next ultimate vehicle, however, wanders the seas almost without a sound. This ultimate vehicle is dangerous and fast. The U-212A, one of the world's most modern submarines, and the first with fuel cell propulsion, designed for the silent and invisible defense of home waters. The first submarine of this class was put into service in autumn 2005. It can reach a speed of almost 20 knots, travel 8,000 nautical miles without interruption, and stay underwater for over 2 weeks. A record for a non-nuclear submarine. Taranto, the home port of the Italian submarine fleet. The SSK Todaro is one of the 4 212A class subs Italy has. At 56 meters long and 11.5 meters high, it is considerably smaller than a nuclear submarine. In return, it is more versatile, for example, in shallow coastal waters. Its sail is one of the shortest in the world, making the sub extremely streamlined and fast. Like the rest of the outer hull, it is made of fiberglass reinforced plastic, a material difficult for sonar to locate. Tomorrow, the submarine is scheduled to depart on a training mission. Captain Giorgio Marini Bettolo coordinates the preparations.
Tomorrow we will leave for a 30 days mission. It will be an intelligence mission, and the Todoro, the boat of the 212 class, is the perfect submarine to do this kind of mission.
As opposed to its predecessors, this submarine has 2 decks. The upper contains the operations center and the sleeping quarters for the 32-man crew. The lower deck contains the entire propulsion unit and 6 torpedo tubes. Chief Engineer Fabio Nicoletti is checking the fuel cell. It needs no external air, it generates no fumes, hardly any heat, and above all, no noise. Thus, it enables a long and nearly invisible deployment.
The first thing I thought when I heard about the possibility of the fuel cells on board of Italian submarines was that we could at least become as powerful as nuclear submarines and becoming air independent. And this allows us to say to be a very strong and efficient asset at sea to do our missions.
The energy from the fuel cell flows into a battery, which in turn powers an electric engine, which drives the propeller. But there is a diesel engine on board too, used for surface cruising.
I will open this door. We need to protect our ears because now the sounds get higher.
That the deafening noise in the engine room cannot be heard outside is thanks to a unique design adopted for the 212A class. The diesel generator and other loud components and machines are arranged in a kind of capsule made of super sound-absorbing material, which is slid into the hull as one unit. In addition, this capsule is resiliently mounted in the submarine's hull, such that no vibrations are transmitted to the outer hull. Because the less noise a submarine projects on the outside, the more invisible it is. The 212A class was developed in the German Howaldtswerken, today ThyssenKrupp Marine Systems. Here, each submarine is crafted by hand. Build time over 6 years. Peter Hausschild is a shipbuilder and collaborated on developing the U212A.
The 212 class was a real technical challenge, as it used many technologies for the first time. For example, we made use of very large-scale fuel cells that perhaps had not been serially produced since the Apollo program.
The history of German submarine building began in 1850, when Wilhelm Bauer constructed the Brandtaucher, one of the world's first submarines. A good 60 years later, there were already 141 submarines in the Imperial German Navy. Over time, the submarines got bigger, faster, and could dive ever deeper and longer. With the 212A class, the first of which was put into service in 2005, Germany developed one of the world's most modern submarines, a development that attracted attention worldwide.
The US Navy was very eager to test the subs and see if it could find them. So subs from the Italian and German navies went to the US to perform maneuvers, and the Americans had great difficulties finding them.
6 submarines of the 212A class are operated by the German Navy, whereas 4 have been sold to Italy. Taranto, early morning. The 32-man crew gets ready for its 30-day mission.
We are ready for our mission.
While the last crew members stow their gear on board, the operations center prepares for departure. And then it's time. The SSK Todaro launches. submarines of the 212A class have two cutting-edge periscopes with a thermographic camera, laser rangefinder, GPS antenna, and night vision capability. The crew will check systems such as steering and sonar on a dive near the harbor. For during the maneuver, at a depth of 200 to 400 meters, everything must work perfectly. After the last hatch is closed, Captain Bertolo gives the command to dive.
Immersione. Timoniere governa per quota 14.
Quota 14. Immersione. Timoniere governa con massimo 3 gradi approvamento. Apri allagamenti. Apri allagamenti. Apri 1. Apro 1. 2 aperti. Apri 5. Apro 5.
First, the submarine dives to periscope depth, just under the water's surface. To this end, the engineers slowly flood the 5 ballast tanks. 150,000 liters of water rush into the tanks and press the sub underwater.
Timoniere quota 40.
Quota 40.
Using the X-rudder at the stern and the fair water planes on the sail, the helmsman takes the submarine down. How deep a submarine can dive is a well-kept secret. The U-212A class is supposed to be able to dive to more than 400 meters. For this test, the submarine will now dive to a depth of only 40 meters. The crew begins with the tests right away.
We will do a safety check from the different stations.
Next to fire, the greatest enemy of a submarine is water. The crew checks every spot where water could theoretically get in.
Ronda eseguita in tutti I locali con esito regolare.
Then the 6 sonar systems are checked. They are the submarine's underwater eyes and ears.
This very modern sonar allows us also to capture noise at very high distance and in many cases also at more than 100 kilometers. So it's a huge distance and this gives us a huge advantage in the operations.
The sonar systems are also very accurate. The sonar engineers not only hear whether a military, container or cruise ship is in the area, but often they can even pinpoint exactly which ship it is. After a good hour, all the tests are complete and the SSK Tadero prepares to surface again. To this end, the helmsman uses the rudders to rise to just under the water level. Captain Giorgio Marini Bertolo looks through the periscope to see whether it is safe to surface and no other boat is in the way. He can see up to 20 kilometers with the periscope.
Direttore, emersione. Alza 15.
Timoniere governa con massimo 3 gradi appoppamento. 3 gradi appoppamento. Apra allagamenti.
To rise, compressed air is blown into the ballast tanks, thus pressing the water out. This process lasts about a minute. In an emergency, though, the submarine could surface from a depth of several hundred meters within 30 seconds.
We are ready for our mission and we are looking forward to start it. And we are really lucky to start our mission on this kind of submarine, which is a really powerful asset.
Many ships travel the 7 seas, but only a few are as fascinating as these ultimate vehicles. They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain, and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air, all of them are ultimate vehicles. In this episode, Giants of the Skies, the biggest passenger aircraft in the world. When cargo is too bulky for other aircraft, this giant goes into action, the Antonov 124. A jumbo jet that flies with the hatch open, the biggest research aircraft in the world. An airplane for $70,000 an hour. The first Boeing 787 designed as a business jet. And the ancestor of all modern airplanes, the DC-3, used in the Amazon basin. It is the king of the skies, the Airbus 380. The biggest and also the heaviest passenger airplane on Earth. Its maiden flight was in April 2005. The 70-meter-long plane has space for up to 853 passengers. And with its 80-meter wingspan, it is wider than a soccer field. Germany, Frankfurt Airport. Germany's largest airport is home to Lufthansa's A380 fleet. Every 8 days, a service check is performed. Landing gear, engines, wings, empennage, and electronics are checked, just like the plane's interior. The two passenger decks are as large as 2 tennis courts. According to Airbus, these are the largest and most comfortable cabins around. Joachim Schwarzenberg and his 2 colleagues are among the airline's 370 pilots qualified to fly the A380. Their destination today, Hong Kong. They head to the airplane with the 21 members of the cabin crew. Another record. The airline puts such a large cabin crew on no other airplane.
Every time you come here, you're impressed by the size, by everything. You see all the baggage, like a whole village is about to fly through the air. More than 500 people. It's really quite special.
Joachim Schwarzenberg has been flying the A380 for 7 years. In addition to the size, it is above all the cockpit that thrills him. It is the most modern in the world.
This is a real evolution with respect to the last generation of planes. We now have an interface between the screens. We have a keyboard here, which lets us work differently. And the plane is in communication with the ground the whole time.
Errors and problems are recognized much sooner. Yet, despite state-of-the-art technology, a final exterior check before takeoff is required. Captain Joachim Schwarzenberg looks for tears in the exterior skin, for dripping lines, and checks the 22 wheels.
These are truck tires in Formula One format. They have to hit a speed of 360 and be able to handle it. So it's important that they're all okay.
While Joachim Schwarzenberg checks the last parts, 15 meters above him, the last passengers board the plane. The A380 can carry as many as 853 passengers. Lufthansa offers only 509 seats on the A380, but this is still more than on the second largest plane, the Boeing 747. Almost the entire upper deck on this A380 is reserved for first and business class. The so-called main deck is home to the cockpit, 7 galleys and over 400 economy class seats. The lower deck has places for the crew to sleep and plenty of space for luggage and extra freight. After all passengers have boarded, the 11-hour flight to Hong Kong begins.
I'm releasing the brake, and we can push back.
This is very hard work for the aircraft tractor. Fully loaded and refueled, the A380 weighs a hefty 560 tons. Then, Captain Joachim Schwarzenberg starts the 4 powerful Rolls-Royce engines.
ready.
Stabilized. Take off.
Despite its gigantic proportions, the A380 does not need a longer runway than any other wide-bodied aircraft. After fewer than 3,000 meters, it lifts off. Toulouse, France. This is where final assembly of the A380 takes place. In only 4 weeks, this aircraft is assembled from over 4 million individual parts and over 500 kilometers of cable. Richard Cacaillet is the company's head of strategic marketing and has closely followed the airplane's development.
At the end of the 90s, air passenger volume rose so drastically that the largest plane to date, the Boeing 747, was no longer big enough. Airbus was still a very young company at the time and wanted to expand in the sector in which Boeing had had a monopoly for 30 years.
It took just about 5 years and $12 billion to design and build the first A380. The engineers were confronted with serious challenges.
State-of-the-art technology was necessary in every aspect. Aerodynamics, materials for reducing the aircraft's mass, and the engine, designed to consume 15 to 20% less fuel per seat compared to the 747.
To meet these needs, the engineers chose a form that was entirely new. In contrast to the Boeing 747, the A380 has 3 decks that stretch over the entire fuselage. This makes the airplane more streamlined and thus more aerodynamic. But the true revolutionary thing is the lightweight construction. For the first time, glare was used, a laminate composed of aluminium and glass fiber. As a result of using new materials like this, an empty A380 weighs about 15 tons less than a comparable traditional airplane. On the 27th of April 2005, it was ready. With 2 test pilots and 4 engineers on board, the first A380 took off for a 5-hour maiden voyage. In an emergency, the 6 testers could have parachuted out of an escape bay, but the flight experienced no problems. Richard Cacaillet still remembers this day well.
Alors c'était un premier vol comme chaque programme en a.
Working on a program like this that lasts 8 years, with an airplane for which you've developed a certain affinity, when the first flight takes place and everyone is watching and inspecting the plane, that is a special feeling. And everyone clapped.
Très forte, très forte. Et tout le monde applaudit. Tout le monde applaudit alors que bon, c'est un avion qui décolle.
Despite initial problems with series production, the A380 is today used by 13 airlines and is among the safest and most reliable airplanes in the world. This Lufthansa A380 has meanwhile almost reached its destination, Hong Kong. Captain Joachim Schwarzenberg and his colleagues are preparing the approach.
The A380 actually lands very nicely. We have to pay attention to the mass, of course. The mass is so great that we must do everything a bit earlier to make up for inertia.
During landing, the so-called brake-to-vacate system is used. First employed in the A380, it calculates the optimal braking distance and automatically activates the brakes at a predetermined point on the runway. The landing itself remains the job of the pilot, however.
100. 50, 40, 30, 20, retard, retard, retard.
After 11 hours in the world's biggest aircraft, the 508 passengers have reached their destination. Joachim Schwarzenberg is satisfied with his plane.
This plane was amazing. I would pet it if I could.
The crew will rest for 2 days, but in 7 hours, the A380 will take its next 508 passengers to their destination. Later in this episode, the AN-124, the biggest serially produced cargo plane in the world. Originally designed for transporting rocket launching ramps, today it is used in civil aviation. From the modern pinnacle of passenger air travel to its very beginnings, this next ultimate vehicle opened the skies to the masses. It is a legend.
The father of modern air travel.
Something from this ultimate vehicle is found in every modern airplane. The DC-3, a revolutionary plane that ushered in a new era of flying. And a good 70 years after it stopped being produced, it is still being used. The Douglas DC-3 completed its maiden flight on December 17, 1935. It is almost 20 meters long and has a wingspan of about 30 meters. More than 16,000 aircrafts of this type have been built in total. Hundreds of DC-3s are still flying in many places, but nowhere as regularly as in Villavicencio in the middle of Colombia. The small city is about 100 kilometers away from the capital, Bogota. This is where the legendary airplane takes off and lands. More precisely, at La Vanguardia Airport. From here, the DC-3 regularly flies important aid supplies to the Amazon region, just about unreachable by car. The flight lasts 1 hour. The DC-3's great advantage: it can withstand mighty gusts and very heavy rainfall. According to myth, it can even land without a pilot. Be that as it may, Germán Romero sits in the cockpit every day. As pilot, he is also responsible for the entire cargo, and today for something special too.
There's a music festival at our destination. So, we're also taking a porta potty and many instruments for the musicians.
While cargo is being loaded at the tail, technicians check the front of the aged plane and refuel it. Everything manually and more or less according to feeling. There are no electric fuel gauges. No wonder, considering the aircraft's age.
The aircraft is 81 years old. And I've logged over 20,000 flight hours with it. I've been flying it for 38 years.
No mistakes are allowed during the inspections. Germán Romero has already made it through many dicey situations with the plane, and he has faith in it precisely because of its simple design.
In my view, it is the safest aircraft by far, in all kinds of weather, with incredible performance. The father of aviation.
More DC-3s have been produced than any other passenger airplane in history. In Colombia, it is an indispensable means of transportation. To maintain the plane's balance, the crew weighs every piece of baggage by hand to determine its place in the cargo hold. Loading is complete. Germán Romero moves into his living room, the cockpit. Computer and high-tech equipment are nowhere to be found. But that doesn't bother the experienced pilot. On the contrary.
This is an aircraft that is simply fun to fly. Many people are trained on it because you have to be able to fly with this aircraft.
The runway is clear for takeoff. The 8 tons of flying metal start moving. From this point on, it's all a matter of feeling and muscle strength. There are no hydraulic systems. In flight, the DC-3 is uncommonly easy to handle. Its design lets it fly very smoothly. This is thanks to what was at the time an innovation in aircraft construction. In all pre-DC-3 models, the wings are at a right angle to the fuselage. But the plane's creators discovered that an arrow-shaped wing design shifts the center of gravity, thus improving stability. This innovation continues to be incorporated in modern airplanes. In addition, designers came up with a trick to reduce turbulence, a small curvature where the wing meets the fuselage. All this makes Germán Romero's work easier. Still, the classic plane doesn't fly itself.
Takeoff is the hardest part, but landing is the most dangerous.
Mechanics carry out daily maintenance to keep the DC-3 flying smoothly. In Colombia, this takes place not in an orderly hangar, but on the side of the runway under a blazing 40-degree sun. All under the watchful eye of Chief Mechanic Mario Parra. Spare parts are taken from old planes that are no longer fit to fly.
It's an old plane, but it's so well designed that it can fly with only one motor. As long as we maintain it, everything is fine.
The engine technology and wing design were revolutionary. And even today, the DC-3 is considered tough, flexible, easy to operate, and easy to maintain. All the parts are welded together with 500,000 rivets. The DC-3's history begins with supply problems at the competitor, Boeing. Trans World Airline needed airplanes and asked Douglas to design an aircraft. This was the birth of the DC-3 and thus of commercial air travel. Since it needed less fuel, flying became affordable. The new airplane was also supposed to be bigger. Till then, bigger had always meant longer, but not with a DC-3. Earlier planes had a square fuselage. But this shape put limits on size. The DC-3 was designed with a round fuselage, which provided greater stability. Structural shapes still in use today. Only the electrical systems and individual parts of more recent airplanes have been improved, and thankfully so.
Most of the DC-3's problems are the same as in other planes, but one crops up frequently. When it rains a lot and the engine gets wet, then the electrical system goes haywire as the old parts get moldy very quickly.
Problems not faced anymore by mechanics dealing with modern airplanes. Nevertheless, people in Villavicencio still keep on flying the DC-3, especially due to its ability to land on non-paved runways when flying to remote Amazonas regions. Like Germán Romero does. The flight to La Macarena lasts about 1 hour. A small onboard computer gives the pilot information about altitude and GPS position. When there is room, the plane also takes passengers. Being a pilot is a dream job for many people, including Germán Romero.
I always wanted to become a pilot, even as a young boy. And now I've been in the pilot seat since I was 18. It's the best.
The approach to La Macarena Airport, especially difficult due to extreme crosswinds and heavy gusts. But Germán Romero nails this landing too. Not perfectly, but safely and skillfully.
The flight was good, but we had really strong winds while landing. It wasn't easy, actually somewhat rough. Otherwise, perfect.
Another successful deployment for the DC-3 here in Colombia's Amazon basin. The over 80-year-old classic airplane has succeeded in bringing important goods to the remote location of La Macarena. And today's load also includes the porta potty for the upcoming music festival. Outstanding loading capacity and a nose that opens. Later in this episode, the biggest serially produced cargo plane in the world, the Antonov AN-124. The DC-3 made flying a pleasure for the masses, but there are still massive status differences in the skies. This so-called dream jet is the first 787 business jet, and at the same time, one of the most luxurious business jets in the world. The Boeing 787 is the most modern commercial aircraft in the world. A business model was first unveiled in May 2016. It can fly 16,000 kilometers non-stop. This 224 square meter plane provides space for 380 people on commercial flights. The rent for the business model is $70,000 per hour. The home airport for this 787 is Haikou, on the island of Hainan in southern China. Aloof from normal air operations, the Dreamjet awaits its next assignment. With a wingspan of 53 meters, a height of 17 meters, and a length of 56 meters, it is one of the biggest business jets in the world. Jessie Mi Shanpan is the 787's cabin chief. She makes sure that its upscale passengers want for nothing.
We just received a trip request from the owner, and he wants to fly to the States, so it's going to be a long-haul operation for us, a lot of work, but we'll have to make sure the cabin's ready and it's perfect for him to fly later on.
Today, for the first time ever, a film crew is allowed to get a closer look at the exclusive luxury airplane. The first stop is the main cabin, which serves as a lounge and conference room. There is room for up to 16 people. Like normal airplane seats, the luxurious sofas and armchairs are outfitted with seatbelts and life jackets. In the back, there is place for 24 more passengers. The 18 first class and 6 business class seats are for the crew and the client's attendants. Here too, a premium was placed on appearance and luxury. The galley is located in the tail of the airplane. For safety reasons, it is a standard galley, like in every other 787-8. The lounge and the first and business class area take up most of the airplane. The tail provides just enough space for the galley. The front of the 787 contains private rooms for the main client. A bedroom as large as a whole apartment, including a king-size bed, and an adjoining luxury bathroom. Next to the bedroom, a narrow passage leads to the cockpit. Only a handful of pilots are allowed to fly this 787. In the main cabin, Jessie Mi Shanpan and her team prepare everything for the upcoming flight. In less than 2 hours, the client will be there, and there is much to do.
We also need to test to see every seat are working. So we were doing the testing. This is good.
All the cabin electronics, like the adjustable sofa, multimedia devices, and the lights, can be controlled from a central unit. In addition, 42 kilometers of cable were laid and 17,000 electrical connections installed. The electricity comes from alternators on the engines. The 787's engines are especially economical. Normally, hot compressed air, so-called bleed air, is taken from the airplane's engines. It is then used to maintain cabin pressure, among other things. The missing air makes combustion in the turbine less efficient. In the 787, however, this air comes from intakes in the fuselage and is then compressed electronically. The engines work more effectively and consume less fuel. Jessie Mi-Shan-Pan and her team are preparing the bedroom for the client. In addition to exquisite materials like cashmere and satin, a 42-inch television awaits the client.
This bedroom, because of the material of the wall, and you can feel it, the texture. Yeah, because of these materials, it can keep the noise down to a very low level. Even when we're flying, it is under 48 dBs.
That corresponds to the noise level in a normal apartment.
So we have different light scenario for the lighting that makes our job very easy. For example, we usually keep the bedroom lighting to relax.
And this is where the 787 Dreamjet comes from, Everett, near Seattle, in the US. This is the home of Boeing's main plant. Charles Coburn is Director of Marketing and sees to the exclusive clients who want to buy a 787. In his view, the 787 is one of the best airplanes for a private jet.
It's the only airplane that is all composite. That lets you do so much. You know, increasing the humidity so you don't have to worry about corrosion 10, 20 years down the line.
80% of the 787 is made of composite materials. The Dreamliner is about 20% lighter than an aircraft of comparable size.
Range is essential for a business jet. The 787 BBJ has the capability to fly nearly 10,000 nautical miles, which means you can go non-stop anywhere in the world that you want to.
For example, from China to the US, the route for which the Dreamjet is being prepared today. At this moment, the food for the long-haul flight is being delivered.
Sometimes they want McDonald's or Kentucky, but this time he wants catering from this hotel.
After the choice food, which must be paid for separately, is stowed in the warming cabinets, the cabin chief begins her final inspection.
Usually at the end of the check, we will have to sit on this seat because this is the seats that the principal client usually sits. When we check the cabin, we simply walk around and then we might be in different eye level. So we usually sit in here on his eye level and we might be able to pick up something wrong. It looks everything good now, finally, and we actually have not enough time today, but I think we're able to make everything perfect, and we'll wait for the client to board now.
In only 2 hours, Jessie Mi-Shan-Pan and her team have prepared the 787's 224 square meters according to the client's wishes, down to the last detail. Now, the client can come. Later in this episode, a jumbo jet filled with technology and a 20-ton telescope. Sophia, the biggest research aircraft in the world, provides images of remote galaxies. From a capricious luxury airplane to a true working horse of the skies.
It's absolutely unique. There is nothing like it.
The Antonov AN-124, the biggest serially produced transport aircraft in the world. On December the 26th, 1982, the Antonov took off for the first time. The Giant's cargo hold, with a volume of 1,040 cubic meters, can load up to 150 tons. Production cost up to $80 million US. Today, the AN-124 is still flying cargo around the world. The next stop, the East Midlands in Great Britain. Logistics manager Tom Blakeman is waiting here for the giant to arrive. Even for this airport employee, it is a special event every time. It weighs 400 tons and has engines as big as a car. So far, only 56 units have been produced. The Antonov is employed for exceptionally heavy transports. Tom Blakeman speaks with the flight manager.
Yeah. What time will you...
Pick up from hotel at 8 o'clock local.
Yep.
Then at 9 o'clock we start prepare aircraft for loading.
Yeah, okay.
In the giant's belly. Here it is not the length that matters, but the height. Loads of up to 4 meters 40 centimeters fit in the cargo hold. That's a world first.
It's always an awesome sight as it's taxiing towards you, yeah? And I think that's really the awe of it before you enter the cargo compartment. But once you enter this place, it's very much like a warehouse, a cathedral even.
For the AN-124 to be able to transport its heavy cargo, its designers had to take the engines to their limits. 4 turbines ensure that the giant reaches a maximum speed of 865 kilometers an hour.
Outsized machinery, aero engines are all designed to the maximum dimensions of that aircraft because they know that's the only way to fly it. There isn't a Western aircraft that can come close to it.
10 main landing gears, each with 2 wheels, ensure that the giant can land safely. The 2 nose landing gears have double tires and can even be retracted. For the AN-124's true highlight, cargo can be loaded in the front and in the rear. As opposed to other aircraft, the Antonov needs no ground-based aids, like loading ramps or lifting platforms. Rather, it is entirely self-sufficient. Today, the crew must also face a special challenge, quickly loading a 60-ton alternator and then transporting it to Seoul, South Korea. For the Antonov's charter flight, the client pays up to 300,000 euros.
Get going, kids. Once it's on, we're done.
Once the alternator is on the rails, 2 winches pull the €5 million cargo into the belly of the transport aircraft, all under the watchful eyes of the loadmaster, Sergei Bulachenko.
Loading finished on time, indeed 15 minutes early. So everyone's happy. It's all good. Now we're taking a break, since our work is done.
In the cargo business, lost time means above all, lots of money. 4 hours after loading began, the giant's nose closes. Originally, the AN-124 was developed as a strategic military transporter for the Soviet armed forces. An advantage, thanks to the flat ramp in the nose, armored track vehicles can drive directly into the cargo hold from the ground. In addition to easy loading, the Antonov also scores with another feature. The air pressure of the tires can be adjusted in flight by a whole 30%. Thus, the transport plane can also operate on unprepared runways or on hard-packed snow. Whether on a gravel track or asphalt, the Antonov is versatile and robust. As a result, it has achieved a monopoly that endures today. About 1.5 hours before takeoff, the 6-man cockpit crew arrives at the airport. Flying the giant requires a captain, a co-pilot, 2 flight engineers, a navigator, and a radio operator. Evgen Bashinsky is finishing his training as an Antonov pilot. For the 32-year-old Ukrainian, the cargo plane is one of the most thrilling aircraft of our time.
Computers make his job in modern aircraft. But here we should have a radio, navigator, flight engineer who control all the instruments and systems of this aircraft.
The airplane was designed in the late 1970s. Thus, every instrument must be operated and checked by hand. But for Evgen Bashinsky, this is not the Antonov's biggest challenge.
One thing make this aircraft harder to control, harder to operate. Not each airport can provide enough clearance for us.
Behind the cockpit, there are quiet rooms for the crew. The crew travels with the AN-124 around the world for up to 3 months.
In this chamber, we have a small kitchen.
No routine emerges. Every assignment is unique.
You never get over familiar with this airplane because every time it comes in, you always learn something new about its capabilities.
After 7 hours, the giant takes off again. The next destination, Korea. The Antonov AN-124, truly an ultimate vehicle. The next ultimate vehicle transports the same heavy cargo every night, a 20-ton telescope. This is no normal airplane, but rather the biggest airborne observatory in the world, in the hull of a Boeing 747.
It's absolutely a privilege to be here and do this.
There's only one Sophia in the world. There's no replacement.
SOFIA is an acronym for Stratospheric Observatory for Infrared Astronomy. Its objective: to study star-forming regions, planets, comets, and interstellar medium on the basis of the infrared rays they radiate. The Flying Observatory has been in use since May 2010. The cost of development and retrofitting, $1 billion. SOFIA is actually a short version of the Boeing 747. It has a range of about 10,460 kilometers and can reach a maximum altitude of about 14 kilometers. SOFIA's base is in the US, at NASA's Neil Armstrong Flight Research Center in California, on the edge of the Mojave Desert. Until the maiden flight of the A380, the 747 was the biggest passenger aircraft in the world. The raised nose and the bulging cockpit make the jumbo jet one of the few airplanes whose silhouette is immediately recognizable. SOFIA is a project of NASA and the German Aerospace Center. Engineer Oliver Zeiler checks the core element before every mission: the infrared telescope. He does this in the command central, the former passenger cabin. The tail contains the telescope's mechanical system, which compensates for the plane's movements.
It's very different from flying with a normal plane. If something goes wrong on board with the telescope, you feel a little pressure and some tingling trying to fix it as fast as possible, but it's fun.
All right, welcome to Flight 391. Takeoff at 2028.
The weather is always important, as it influences the telescope's accuracy during the flight.
Two areas of issue right now: the British Columbia, almost all entire British Columbia. A lot of turbulence been reported today.
If it is too strong, the telescope stops working. Shortly before takeoff, flight engineer Moose Peer performs his final check.
Turns the aircraft over to ops, we take responsibility for that.
40 minutes before takeoff, the pilot, scientists, and engineers are on board. Now for something everyone is familiar with before a flight: the safety instructions. In the meantime, Moose Pier and the pilots prepare the 747 for takeoff.
Are you guys ready for start down there?
Ready for engine start.
Thank you. This is pilot. You guys ready to start down there?
We're ready for you to start whatever you are.
Okay, we'll start 2 and 3.
As opposed to a standard passenger aircraft, Sophia takes an extremely long starting run. The idea is to go easy on the fragile devices on board, especially the 17-ton telescope in the tail. After takeoff, the pilots give steady full thrust to gain altitude as fast as possible. The goal? To maximize observation time for the scientists. Tonight, they plan to examine the composition of the atmosphere of various stars. Missions like this take place exclusively at night. The telescope cannot be used during the day.
This mirror has a diameter of 2.5 meters, a parabolic mirror. When sunlight hits it, it naturally focuses the light on a point. And this point, in the posterior cavity where the telescope is, gets very, very hot. It can reach several hundred up to 1,000 degrees. And that would be dangerous for the plane.
In addition to flying at night, altitude is also crucial for studying the universe.
We do operate them higher than most airlines would like to. And the whole reason for that is the higher you get, the less atmospheric moisture is. Moisture is one of the things that obscure the science observation. So the higher you get, less moisture equals better science.
The aircraft reaches an altitude of 10,700 meters, perfect for opening the door to the telescope.
And it should be moving. Door moving.
And now, the unbelievable happens. A huge hole opens on the side of the 747. Every passenger's nightmare. But this time, it's on purpose. And at a speed of about 1,000 kilometers per hour.
When the door opens, you don't hear it or feel it. The pilots don't feel it in the airplane's trim. You don't really even notice it at all.
There's a fairing back there that creates the airflow to not get in the telescope assembly, so it's a pretty brilliant design.
With the door open, air should rush into the airplane. The result? Increased fuel consumption and air vibrations that would disrupt the telescope's aligning accuracy. And over time, damage the airframe. This is avoided thanks to a sophisticated covering in front of and behind the door. It leads the air current away from the telescope. To keep the plane steerable, behind the opening, the air slides along the plane to the empennage. In this way, Sophia can fly steady even with a huge hole in its side. Sophia is at the forefront of technology. It was designed and built over a period of 20 years. Today, project leader Eddie Zavala is in charge of this unique plane.
When you first see Sophia, many people tell me that their first reaction is, wow, this is a big airplane. And it truly is. It is the world's largest airborne observatory.
Sophia's basic frame is a modified Boeing 747. The idea was to combine the biggest airplane of the day with the biggest possible infrared telescope. The aircraft was disassembled into 3 pieces and then put back together by the same company that builds Air Force One for the American president.
There were a lot of engineering challenges, primarily, first of all, putting a 17 metric ton telescope with a 2.5 meter primary mirror in the back part of the airplane with a door that opens up without causing aeroacoustic resonance. If we had had acoustic resonance when we opened the door, Sophia would sound like a train whistle as the airplane is flying at 500 knots.
Another challenge. The big telescope makes the airplane tail heavy. Thus, a counterweight is provided by tungsten plates under the cockpit. The scientists are observing objects in the night sky that are light years away. The telescope always maintains the same position, compensating for the airplane's movements and turbulence.
Right now, as you feel this little light turbulence, this little chop, the telescope assembly is stabilized, and it's kind of like a rigid in space. It's almost like a flying gyro.
But today, the telescope is taken to its limits. The turbulence is too strong, and the telescope no longer responds to computer commands. A mad rush at mission control on board. The problem is quickly found. There's no electricity.
What are you proposing for a solution here? Just want to take everything down like you originally planned. All right, so we've got one shot to reboot that, to reset that's the circuit, right?
Rebooting the system, a big problem, a simple solution, but not simple for a priceless plane while still in the air.
There's a mission rule on board. When a circuit breaker trips, you can reset it once and continue. But if it trips again, then it is clear that there is a problem somewhere in the device, and then you can't keep trying to reset it 2 or 3 times. And you either have to keep this system turned off, or the mission is over.
A catastrophe for the scientists. They often work on their research for years and have only this one moment to test their theories. Thus, Oliver Zeiler and the engineers on board must resolve the problem as fast as possible.
Now I feel better. We resolved everything and the scientists are happy again. We're observing again, collecting data. Yes, now it's working again.
The telescope and the computer are working again, according to plan. The mission has been salvaged and much money saved. The flight's kerosene alone costs 80,000 euros. Oliver Zeiler and his engineering team make sure that the telescope performs dependably. The airplane itself is constantly being checked by Moose Pier. It fascinates the flight engineer as much as it did on his first day.
It was kind of overwhelming that, you know, you can take something that is such a modification and actually get it airborne. And you think about all the coordination and the teamwork that takes place to make every mission work is fascinating every time you fly.
Sophia's research missions are planned until 2030. What happens after that is unclear. Until then, the 747 operated by NASA and the German Aerospace Center remains the only and the biggest airborne observatory in the world, and a true ultimate vehicle. They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technologically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air. All of them are ultimate vehicles. In this episode, a jet for around $90 million, the F-35 Lightning II. A bomber with a maximum life expectancy, the B-52 is foreseen to be in service for almost 90 years. A jet to teach American bombers the meaning of fear, the legendary MiG-15. From the same manufacturer, the MiG-29 is for many still the best dogfighting jet in the world. And finally, the most modern military transport aircraft in the world, the A400M.
That technology makes it undefeatable in the battle space.
It's going to change the way we fight wars.
The Lockheed Martin F-35, the most expensive defense project in the world. A fighter jet that almost makes flying child's play, in part because it lets the pilot focus entirely on flying the plane. The F-35 completed its first flight on December the 15th, 2006. It can reach a maximum speed of over 1,900 kilometers per hour. Cost per unit, currently about $94 million. Phoenix, Arizona. Luke Air Force Base. The largest base for the F-35 is located here in the American desert. The United States military has ordered a total of 2,400 aircraft for about $400 billion, thus making the jet the most expensive defense project of all time. The home of the 61st Fighter Squadron of the US Air Force. The pilots here are trained to fly one of the mightiest stealth jets in the world. One of them is Major Will Andreotta. He has been flying this technological wonder for 3.5 years. Before heading for the aircraft, Major Andreotta puts on vital equipment. Especially important, pressurized trousers.
This will allow the blood that basically rushes down from the head to the feet when we pull those high Gs to be pushed back up, so we're able to keep consciousness while we're flying.
The jet sets new technological limits, and pilots are physically at their absolute limit.
So we're really well trained. We do this every day. We take it very seriously. So there's really no nerves whenever we go out there. It's just kind of the excitement and the anticipation of accomplishing the mission.
One thing left, the helmet. And it is considered the F-35's secret weapon. No one is allowed to examine it closely, but it is designed to make flying far easier. Before takeoff, Major Andreotta gets his flight briefing from the top 3 of the day. Major Jason Hall.
Ready.
All right, good morning, Lightning Flight. Welcome to the step brief. As far as the weather status, we got scattered clouds at 22,000 feet and winds are out of the southwest. You'll be stepping to aircraft 5069 today. There are no previous issues. Don't forget to bring your publications with you and sign out before getting to your jet. Any questions for me?
No questions. Bring it on.
Now it's time to go. The final steps in the air-conditioned office before heading out into the blazing Arizona heat, where one of the best fighter jets awaits, but also one of the most controversial. For its horrendous development costs have exposed the project to enormous criticism. The mechanics turn the jet over to Major Andreotta.
Good afternoon, sir. How are you doing today?
How are you doing today?
Excellent.
Awesome.
Are you all ready to fly?
Ready.
It looks good.
In every situation, even in wartime, the procedure is the same. The pilot is always responsible for the final check.
This is kind of my last little check just to make sure that all the T's are crossed and all the I's are dotted, you know, and make sure that I'm 100% comfortable when I get into this aircraft. But as I said, these guys, they're professionals. I have no qualms about going into this jet right now.
On today's schedule, a formation flight. A formation in which several F-35s fly closely together. No simple exercise, and one that requires a special level of trust among the pilots.
Really right now, it's just kind of going to the mode where training takes over. Everything we've learned, everything we've done for the last, for myself, for 3.5 years of flying this F-35 are really going to be put into what I do here in the next 45 minutes until we take off. Wait, I'm waiting for the camera to keep going.
After takeoff, the pilot is supported tremendously by technology during the flight. An innovation from Lockheed Martin, an infrared sensor system. It consists of 6 infrared cameras placed on the jet so as to cover the entire space around it. They recognize firing anti-aircraft positions, which can then be attacked immediately by weapons available on board. Even fighter jets arriving from any direction are detected. The pilot always knows who is friend and who is foe. A stroke of genius from the designers at Lockheed Martin. Here in Fort Worth, the jet has been in serial production since 2011. 3 different versions are built, for a total of 11 countries. Charles Bullness is Vice President in charge of the F-35 and has been there since the first sketches of the jet were made.
One of the biggest challenges is trying to get a 40,000-pound airplane to hover and land vertically. And this is actually the easiest airplane to land. You and I could easily land it, and the front wheel of the airplane would land right on the line on a runway. It's that easy.
The B variant is the only modern fighter jet that can land vertically. The need for wide open spaces is thus consigned to the past, a milestone for military jets.
Be proud of this day, be proud of this moment. The F-35, congratulations!
The F-35 has been received with boisterous enthusiasm at all air bases. Another special feature and a groundbreaking innovation, the inside of the helmet, which functions like a virtual reality headset.
The helmet that we have on this aircraft, no matter where he looks, he has everything he needs not only to fly the airplane, but to fight with the airplane. With a press of a button, he can look down between his feet, and that camera information is displayed on the visor of his helmet, so he can literally see through the floor of the airplane.
One jet is composed of 300,000 individual parts. 1,500 suppliers ensure the highest quality standards. In the American production facility, it takes only a few weeks to assemble the F-35. The cost, about $94 million US. Imperfections are not tolerated. Every time, in every mission, it is ultimately the pilot's safety that is at stake.
Early in my career, I started in flight controls, so we learned very early on that you needed to make this jet safe every day, just to make sure that pilots could always return home to their families. I think this jet is making history. It's the best multi-role fighter in the world. It will be for 50 years. How all the technologies have been integrated to make this jet just an amazing machine is something that makes me very proud every day.
Back to Arizona and Luke Air Force Base. Major Andreotta is set to take off momentarily. He is one of 400 fighter pilots from around the world qualified to fly the F-35. In no time, he brings his jet to over 1,000 kilometers per hour. Years of training in a simulator make the flight a routine job, a job that sometimes includes very special moments.
There are times coming on the way back home or taking off where you just have that second you can just look outside, kind of pinch yourself for you being able to do what you do.
"45 minutes later, Major Andreotta lands the F-35 safely again on American soil. An everyday task for him in this ultimate vehicle. And yet, each time he gets an adrenaline rush that is familiar to only a few people on Earth.
All right, thanks, man. Appreciate it. You too. Thanks. Everybody that works on this plane, flies the plane, we really have a great sense and pride in not only flying the F-35, maintaining the F-35, but also just serving our country and doing something that's bigger than us. So every day, it's a huge honor and privilege to come to work.
All in a day's work for man and machine. The Lockheed Martin F-35, a fighter jet that has set a new benchmark for military jets for many years to come. Also in this episode, the legendary MiG-15, which once taught the West the meaning of fear, and the American long-range bomber, the B-52. The F-35 is without a doubt the most modern jet in the world. But in close-range aerial combat, known as dogfighting, many experts believe it is overshadowed by a 40-year-old model. The MiG-29, a flying legend.
Yeah, great. This is the best aircraft, so...
A dreaded hunter of its day. The Light Fighter Interceptor completed its first flight in October 1977. The MiG-29 has a top speed of Mach 2.3. So far, over 1,600 MiG-29s have been produced. Poland, Minsk Mazowiecki. Home of the 23rd Air Base, the Polish Air Force has flown the legendary Soviet jet for a good 30 years. The MiG-29's characteristic design includes wings blended to the fuselage and leading-edge root extensions, a construction that facilitates high speeds as well as outstanding maneuverability at subsonic speeds. Its unique agility makes the MiG-29 nearly unbeatable in a dogfight. Today, trainer Rafał is taking his student Mikolaj on a training flight with a MiG-29, in which they will run through various aerial maneuvers. Before going up in the air, Mikolaj, the trainee pilot, must first practice in a simulator.
I am just at the beginning of my training, so for me it's not that complicated, but it's a bit difficult for me now, so I will do my best.
Today's training is about air policing, which means to identify unknown aircraft and to react in a flash. In the simulator, the trainers confront Mikolaj with situations that he will also have to deal with immediately once he gets up in the air. In the meantime, mechanics prepare the aircraft for the pilots. They check all the systems again. In an airplane made of 6 million individual parts, many things can go wrong. Thus, the MiGs come here regularly for maintenance. Martin is the head of the maintenance crew and is responsible for the squadron's total of 16 MiGs.
This plane is a legend now because in those years when this plane was appeared, it was, I think, absolutely the most powerful and most dangerous plane on over the world. His radio electronics elements, radio station, radar and the armament system, they're very, very advanced and sophisticated.
The MiG-29 went into serial production in 1982. In its early years, it was a dreaded unknown for the West. Only in 1988 at the Farnborough Air Show did representatives of NATO countries get a closer look at the MiG-29. They were amazed at its extraordinary aerial capabilities.
Now they are 27 years old. The Polish Air Force plans to use these planes during the next 13 years.
For agility and speed, the MiG-29 is still tough to beat. How to deploy these features ideally for air policing is what Rafał and Mikolaj will be practicing in a 45-minute training flight.
It's very fun. It has some capabilities that are unique for the aircraft, like aerodynamics and thrust-to-weight ratio. And it's sometimes very difficult, so you have to be on your feet. Sorry.
During the exterior inspection, Rafał also checks the huge air intakes. For takeoff, they are automatically closed with flaps so that no dirt gets into the highly sensitive engines. Then air enters through intakes on the wings, a unique design. Rafał and Mikolaj start their jet's powerful engines and taxi slowly to the runway. In a real air policing mission, pilots must be in the air no later than 15 minutes after getting the alert. Like most Russian fighter jets, the MiG-29 has an especially robust undercarriage, so that it can also take off from provisional airstrips. Pilots need only 270 meters of runway for takeoff, and in less than a minute, they can reach an altitude of 10,000 meters. This performance is possible thanks to the Klimov RD-33 engines, developed specially for the MiG-29. They are mounted underneath the fuselage in separate pods. This position ensures that enough air gets into the engines during extreme maneuvers, such as sharp curves and steep angles of attack. Only with sufficient air intake can the engines perform optimally. In relation to the aircraft's weight, the engines are so powerful that the MiG-29 can ascend vertically like a rocket, and it almost reaches the speed of sound in vertical flight. Speed and agility were always its obvious advantages. Disadvantages were the short range due to small tanks and the small range of its infrared targeting system. For the MiG-29 was originally designed only for short-range air defense. If pilots embroiled their adversary in a dogfight, they were almost invincible. After 3/4 of an hour, Rafal and Mykolai return from their training flight. The plane lands at a speed of 250 kilometers an hour. Using air brakes and a brake chute, the MiG-29 only needs a runway 750 meters long. The air intakes are closed again for landing. Mykolai has just finished a grueling training session. He had, of course, practiced the maneuvers in the simulator ahead of time. But it all feels very different at an altitude of over 10,000 meters and speeds near the sound barrier.
Yeah, that was fun. I hope I was better than in the simulator, yeah? But we will see.
What matters is the opinion of his trainer, Rafal.
We accomplished everything we briefed, so I'm happy about this. We have some minor stuff to discuss, but most of all was fine. So I'm happy for this flight.
And of course with his plane, the legendary MiG-29. Later in this episode, a flying fortress, the American B-52 Stratofortress bomber. Its combination of payload, range and speed has never been surpassed. The foundation for the MiG-29's extraordinary aerial features was laid by another legend. This fighter was the Soviet Union's first mass-produced jet aircraft, and it shocked the West in the Korean War, the MiG-15. Very robust, well-armed, and extremely agile and fast. The MiG-15 completed its first flight in December 1947. Its job, to attack and intercept heavy bombers as an agile fighter. Its top speed is just under the sound barrier. In total, more than 13,000 of this airplane were produced. The Czech Republic, Hradec Králové, a 1-hour drive from Prague. Here, at a former military airfield, is one of only 12 airworthy MiG-15s in the world, a MiG-15 UTI. With a height of 3.7 meters, a wingspan of 10 meters, and a weight of 3 tons, the MiG-15 is a small and extremely agile airplane with a powerful engine. The MiG-15 was presented to the public for the first time on July the 17th, 1949, at a Russian air display in Tushino. 1 year later, in the Korean War, it shocked the Americans, who until then had enjoyed unchallenged air superiority. In countless aerial battles, Russian pilots taught their adversaries to fear them. Only one American plane, the F-86 Sabre, could take on the MiG-15. This airplane still has many fans, such as Roman Svoboda and Josef Miraki, the owners of the Czech MiG-15. For them, the old-timer is something very special.
This plane is a childhood dream come true. I remember the first time I saw the plane. I was 6 or 7 and lived only 40 kilometers from a military airfield. The planes flew over us constantly. I knew then that one day I would own this plane.
The two men bought their MiG-15 from an American museum in 2013. It took more than a year after transporting the plane to rebuild it and make it airworthy.
This airplane and all its parts are 62 years old, so it's complicated. Luckily, we have original blueprints and were able to recreate some parts, which was especially important for the motor.
Since then, they have been presenting their MiG-15 at air shows all over Europe, and they let passengers fly with them in the legendary fighter jet. Gregory Alexatos from Berlin booked such a flight. The 20-minute experience costs the airplane enthusiast about 3,000 euros.
You're flying a piece of history. Built in '55, you have to have tried it. It's going to rock.
But first, the MiG-15 must be refueled. Its tank holds 900 liters. It can be doubled with drop tanks. In the meantime, Roman, the plane's other owner and the pilot of the MiG-15, goes through a short briefing with his guest. Roman is a former military and test pilot and has experience with a wide variety of fighter jets. But in his view, no other plane can compete with the MiG-15.
It's classic flying, really. It's very easy. The only time you actually have to pay attention would be during landing, since the nose is close to the ground. Apart from that, it's a fast plane. You can do a lot of Gs with it. I'm used to flying fast planes. And for pilots like myself, this is an easy thing to do. It's child's play, really.
No wonder the MiG-15 was the most widely built fighter plane with jet propulsion. Little by little, Gregory is getting nervous for his flight.
You can't let fear get the better of you. Just embrace the fear and pack it away for 20 minutes.
Then Roman starts the MiG-15's engine. It was originally designed by Rolls-Royce in England and was built in Russia under license. It is almost twice as powerful as most other engines from the late 1940s. The MiG-15 needs less than 700 meters for takeoff. Its undercarriage is extremely sturdy. Thus, the MiG-15 could also operate from unpaved advanced airfields. Right after takeoff, Roman demonstrates for his passenger what made the MiG-15 so legendary and dangerous. Thanks to its sturdy semi-monocoque construction, it can withstand up to 8 Gs of force and thus engage in extreme aerial maneuvers. In comparison, today's fighter jets can only manage 1 or 2 Gs more. Pilots in the Korean War also took advantage of these features.
How fast can we fly? 8 and 900 kilometers per hour.
Even at low altitude, the MiG-15 flies close to the sound barrier, as Roman demonstrates with this maneuver called a low pass. That the MiG-15 can fly so fast and remain controllable is due to its wing shape, which was innovative at the time of its development. In contrast to early airplanes, whose wings were at a right angle to the fuselage, the MiG-15's wings are angled backwards 35 degrees. It is only these so-called swept wings that make it possible to fly close to the sound barrier. For near the sound barrier, drag is higher. Thanks to its aerodynamic form, the swept wings offsets this drag. In addition, the MiG-15's wings are angled about 2 degrees downward. This slight tilt improves the airplane's agility. Thus, the MiG-15's swept wings make it one of the best and most dangerous fighter jets of its time. The 20 minutes are over. Roman begins his approach. To keep the landing run as short as possible, the MiG-15's engineers give it extra large brake flaps. Gregory has survived 20 minutes of high G-force. He looks happy, but also somewhat worn out.
It's a once-in-a-lifetime experience. Everyone should try it.
Of course, the MiG-15 is a classic among military aircraft. Also in this episode, the A400M. For a propeller plane of its mass, it can fly unusually fast and high, but also slow and low. That makes it extremely versatile. The MiG-15 was designed above all to intercept heavy bombers. It was a legend of the Cold War, and one day it will be the world's oldest military aircraft in active service.
The range with the B-52 is pretty much unlimited.
Even now, it is considered a jack of all trades.
It is one of the most versatile aircraft ever designed.
Despite its advanced age, it is the backbone of the US Air Force. The B-52's first flight took place on April 15, 1952. The heavy bomber has a range of over 14,000 kilometers at a maximum gross weight of 220 tons. Bossier City, Louisiana, Barksdale Air Force Base, the largest B-52 base in the United States. Originally, the B-52 was developed as a nuclear deterrent in the Cold War. The Americans wanted to be able to use the high-flying bomber to fly atomic bombs into Russian airspace, undetected by Russian radar. Armed with conventional weapons, B-52s continue to be used today. Headquarters of the 20th Bomb Squadron. The men stationed here are trained to fly one of the most legendary bombers in history. Captain Joseph Okai and his crew are preparing for a training mission. A standard B-52 crew is composed of 5 people. The minimum crew is 3. The equipment check is essential.
So what we're doing here is, before every mission, you want to come in here and check your equipment out. Aircrew Flight Equipment does a good job of pre-flighting your helmets for you as far as making sure the right equipment with the right mic and audio. You want to do all this now so you don't have to worry about anything once you get to the jet, and you're really you're good to go for the mission itself.
Before the crew goes on board, they are briefed on current weather conditions.
see what kind of turbulence or weather we have on the AR track to see what to expect basically when we get out there.
Of the 75 B-52s currently fit for service, 47 are located here at Barksdale Air Force Base. After a flight, a B-52 must be serviced for 20 hours before it can take off again. Nicholas Kupferer is responsible for the B-52's laborious maintenance. Even he is amazed by the aged bomber's capabilities.
It can land in crosswinds, which is pretty crazy. Like, if you ever see it, it'll land, the nose would be like toward an angle, and the gear would be straight, so it can land in crosswinds.
What makes this special feature possible? The undercarriage. In a crosswind landing, the pilot can angle the undercarriage up to 20 degrees to the left or right. The wheels come down straight on the runway, whereas the aircraft is at a 20-degree angle, facing into the wind.
Pull a lot of 12-hour shifts, but you know, it's worth it in the end, just being able to see something like this that's been flying for over 60 years.
The US military plans to use the aircraft, last built in 1962, until 2040, making it the world's oldest combat aircraft in service.
Once we start the engines, just let me know what the engines are doing, any torching, anything that's going on with them. Make sure the 747 section is locked up. Anything, tell me about the jet. All right, man. Appreciate it. We'll do our walk around.
Thank you.
At 48.5 meters, it is quite long. With its payload of 31.5 tons, its wingspan of 56.4 meters, and its enormous range, the design was a technical masterstroke. The last check is always made by the pilot and his crew, and still, technical problems cropped up in the past during the flight.
Sortie where the left tip gear refused to come down. We were around a little bit till we lost some fuel, so we got a little lighter so we can land, and came back and landed with one gear still up. So that was, you know, my first time that happened. It was kind of like, oh, you know, still nerve-wracking, if you will, but I was with a very experienced aircraft pilot, and he was fine to go.
With 8 turbines and fuel tanks, the wings are so heavy that outrigger wheels are necessary to support them.
Once everyone comes together, you know the jet's ready to go. You guys can take off. So we did all the mission planning. We got everything done, and you know, after a long day of briefings and all kinds of stuff, now we get to go up there and actually make the mission happen. So this is the best part. All right, guys, ready? Let's do it.
Each one of the 8 jet engines has 13.5 tons of thrust. This enormous power is necessary for the bomber's huge wingspan and its maximum weight of 220 tons. Its size and its supposedly ugly appearance have given the B-52 the nickname Buff, Big, Ugly, Fat Fellow. The construction of a bomber with this range and payload was an engineering milestone. Historian Sean Bohannon is an expert in the history of the bomber.
At the end of the Second World War, the United States realized that it might not have a forward base available in the next war for its strategic bomber force. So that became an imperative. An aircraft that was able to operate from the continental United States and strike any target in the world.
With its payload of 31.5 tons, the B-52 is able to transport the largest array of weapons in the entire US arsenal.
With this B-52D Stratofortress here, this is a prime example of how reliable and sound this aircraft was. This particular model flew 145 combat missions in Southeast Asia. Most of these were anywhere from 12 to 16-hour-long missions.
During the Cuban Missile Crisis of 1962, the B-52 bomber flew an average of about 70 missions a day. During the Vietnam War, a total of 126,000 missions. Such long-range missions are only possible with several air refuelings. The tank can take up to about 142 tons of kerosene. It is also the only aircraft in the US Air Force that can carry both internal and external weapons. Continual upgrades ensure the Stratofortress's versatility. The B-52 uses 3 different braking systems. In addition to air brakes and brake flaps on the wings, it uses a brake parachute that helps to halt its enormous weight. Unique among aircraft of this size. After every flight, the crew reflects on how future missions could be improved.
It's great, you know? After all that, going up there and flying it, always being in the jet's always a good day, you know? Sorry about the loud noise. But yeah, coming back down, we have a lot of things to talk about and debrief. It was a great sortie, but we have some stuff we can improve on, so we'll go back and talk about it in the squadron and make sure we can improve ourselves for the next time we fly.
The B-52, despite its advanced age, it still induces awe. The last ultimate vehicle is another heavyweight of troop deployment. It is the most modern military transport aircraft in the world, the Airbus A400M. Designed for use as a tactical and strategic transporter, it has extraordinary features for an aircraft of its size. The Airbus A400M's maiden flight was on the 11th of December 2009. It can fly almost 9,000 kilometers at a stretch and has a maximum load capacity of 37 tons. Wunsdorf Air Base near Hanover. The German A400M aircraft are stationed here as part of Air Transport Wing 62. One of the planes is now returning from Emari Air Base in Estonia. In only 1 week, several hundred tons of material and equipment must be flown from the NATO base there back to Germany. The A400M, which was commissioned as a joint European project in 2000, has been used by the Bundeswehr since the end of 2014. It provides nearly twice as much space as its predecessor in the Luftwaffe, the Transall. The A400M's 4 turboprop engines are among the biggest in the world. Their 8-bladed propellers have a diameter of over 5 meters. As soon as the aircraft stops moving, work begins for Sergeant Major Andreas, the loadmaster. He is responsible for the cargo hold as well as for loading and unloading.
Here we see the supports, which keep the aircraft from tipping during loading. Then we'll unload the container. We've got to stay on time.
The crew has to complete a total of 3 missions today from Emari. In less than an hour, the A400M is supposed to be back in the air. The containers are secured on the ground with a newly developed locking system. In only 1 minute, the crew has unlocked the cargo. Then they can roll the 5-ton container onto the transport vehicle.
The locking system saves a lot of time. It goes much faster. We're talking about 15 or 20 minutes that can easily be saved during loading or unloading.
As soon as the 340 cubic meter cargo hold is empty, preparations begin for the return flight to Estonia. In the cockpit, Captain Henning, the pilot, checks the data for the pending flight. He and his colleague Kai are among the first pilots who were trained for the A400M.
This is one of the most modern cockpits in the world, and the most modern among military cockpits. Based on the A380 cockpit, it has multiple display. We can display all the data necessary to fulfill our mission. A great plane, perfect for the military.
Furthermore, all the systems are multiply redundant, thus ensuring the greatest possible safety. Now the preparations for takeoff are finished. Fully loaded and refueled, the A400M weighs 141 tons. That it only needs 1,000 meters for takeoff despite this weight is extremely important for tactical missions in the field. On such missions, only very short, makeshift runways are generally available. The flight to Emari lasts 2.5 hours. For the loadmaster, time for a breather. The A400M's cargo hold is a pressurized cabin, like in a passenger airplane. The cruising altitude of 11,000 meters is reached in a few minutes.
Flying with a turboprop at 33,000 feet is just phenomenal. And a speed of Mach 0.68. That's about 400 knots ground speed we're doing. That makes it possible to fly this route several times today.
The A400M can reach a maximum altitude of 12,300 meters, higher than any other propeller plane. This is made possible by the 4 extremely powerful turboprop engines. They were designed specifically for the A400M. The special thing, the propellers turn in opposite directions. This concentrates the airstream at the middle of the wing, ensuring greater lift and better lateral stability. What this does for flight performance is demonstrated rather impressively by this Airbus pilot at an air show. Still, it takes quite a lot of practice to perform aerobatic maneuvers with an 80-ton transport aircraft, such as this so-called inside loop. Wunsdorf Air Base has simulators to train pilots and cargo crew. One is the so-called cargo trainer. It is a one-to-one reproduction of the A400M's fuselage. In addition to Bundeswehr soldiers, those of other nations' militaries train here as well. Today's program includes an exercise in which the cargo hold is converted for passenger transport. The goal, to retrofit the aircraft for the maximum number of 116 seats within 1 hour. Heiko Westermann is an aeronautical engineer and oversees the A400M's introduction into the Bundeswehr.
The
A400M's delivery has been delayed, but for training purposes we can use simulators. For example, this cargo hold trainer where we are now.
The maiden flight itself took place almost a year later than planned. The delivery of a total of 174 aircrafts to the 8 purchasing nations has been delayed by more than 3 years. Problems with the aircraft's parts crop up time and again, such as the newly developed engines and the self-protection measures.
The A400M has already proven itself for air transport, especially with regard to range and payload. Its tactical features still present a challenge to the manufacturer. Once these challenges are overcome, the airplane will be unique for its flexibility.
For the A400M can be deployed everywhere in the world. Snow and ice affect the aircraft as little as heat and dusty gravel runways. The A400M can be refueled in mid-air, and it can also be used as a tanker to refuel other airplanes. Furthermore, it can fly so slow and low that paratroopers and loads can be dropped. And for tactical deployment in war zones, the A400M has decoy flares and various electronic self-protection measures on board. Meanwhile, the Bundeswehr aircraft has almost reached its destination, the NATO base in Estonia. Captain Henning, the pilot, prepares the approach.
We have calculated the landing run. The runway is 3 kilometers long. We need about 1,000 meters to land.
In an emergency, a landing run of only 625 meters would suffice for the A400M. 10, 5. For 8 months, the Bundeswehr has secured the airspace over the Baltic states from Amari. Now other nations will take over the job. Before loading, Sergeant Major Andreas, the loadmaster, checks whether the container is evenly packed and nothing can slide around during the flight. The colleagues on site have done good work though, and after 20 minutes, the 2 containers are loaded and secured.
Loading went great. We'll stow the rest properly, wait for the passengers, and then it's time to go. We'll close up here in a minute, and then we're ready for takeoff.
Fully loaded, the A400M sets off for the return flight to Germany. And in about 5 hours, the most modern transport aircraft in the world will land for the 3rd time today, here in Emari. They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain, and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technologically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air, all of them are ultimate vehicles. In this episode, a super sports car on course to set world records, the Bugatti Chiron. The most powerful of all, a tractor designed for mega farms. Also, the Beast, the biggest snow groomer serving the best skiers in the world. A dump truck as big as a single family house. This Belarusian truck has as much power as 6 Formula One cars. And finally, the most powerful and highest telescopic crane in the world. Hundreds of people worked for a decade to create it. The fastest car in the world pushes technology and physics beyond their limits.
One of a kind among hypersports cars.
The Bugatti Chiron.
At the moment, there is nothing out there that can beat this car.
The Chiron was presented for the first time in February 2016. It has 1,103 kilowatts of power and is outfitted with a W16 4-stroke engine. That means a maximum speed of at least 420 kilometers an hour, and then some. The Bugatti factory in Molsheim, France, is the birthplace of this super sports car. Its production is strictly limited to 500 units, built entirely by hand. Working at maximum capacity, factory manager Christophe Piochon and his team can build about 70 cars per year.
If a Bugatti can be compared to other cars, it's no longer a Bugatti. In production alone, we have more in common with a Formula One car than with a standard assembly line product.
The newest challenge, to break the world record, which dates back to 2005. It was set by a previous Bugatti model, the Veyron, which defined the upper limit of speed at 431 kilometers an hour. No other manufacturer has been able to top it so far. With the Chiron, Bugatti wants to raise the bar it itself set. No easy task and enormous pressure for all involved, including head designer Frank Heil. He devoted 10 years of his life to designing this new model.
I've had sleepless nights and also long nights to meet specific deadlines and find specific solutions.
Their motto, form follows performance. The mammoth task of breaking the top speed of the entire automotive industry requires a very specific visual form. A special challenge for the marriage of technology and design, one that can literally cause friction.
The test phase gave us certain insights, for example, into thermodynamics and aerodynamics, how to deal with the heat of a 16-cylinder engine. We came to a point in development where we should have cut more holes in the car, but of course, as designers, we didn't want that.
The solution, built-in air intakes, integrated seamlessly into the design that ultimately provides for extreme engine performance. It is precisely this high performance that Bugatti test driver Andy Wallace really treasures. The winner of the 24 Hours of Le Mans has already driven a few ultimate cars in his life, and he's not easy to impress.
This car is absolutely amazing, and I've done more than 50,000 kilometers in the car, and every time I jump in the car, I get the same feeling. It's not normal. It's something very, very special.
Andy Wallace personally shows customers how extraordinary it feels to drive the car. Its buyers are among the richest people in the world. Whoever spends 2.5 million euros on a single car expects a unique experience.
So the car is incredibly comfortable and relaxing to drive, but then, of course, if you want, it becomes this 1,500 horsepower supercar with amazing top speed, amazing acceleration.
And that is precisely what all customers want. The path is long, however, before the fastest car in the world can bring excitement to roads and buyers. Each one of these super luxury automobiles spent 6 whole months in the Bugatti factory. About 20 employees prepare the sports car to withstand the most powerful stresses possible. This maximum performance is made possible above all by the brand new high-performance engine.
This is the heart of our vehicle, our 16-cylinder engine with 1,500 horsepower, which of course totally changes the car's dynamics.
Cars with turbochargers normally need some time to react. The Chiron avoids this turbo lag with a sequential setup. When accelerating, at first only 2 of 4 turbochargers are active. Maximum torque is thus already achieved at 2,000 RPMs. At 3,800, the other 2 turbochargers are activated. Full power is reached at 6,700 RPMs.
The fact is, once you've driven a Bugatti and experienced its acceleration, every other car will seem lame.
Visually, the Chiron also sets a high bar for the automotive industry. With each one of these million-dollar vehicles, an employee spends 2 whole workdays on nothing but polishing the surface to perfection. Afterwards, production leader Christophe Pierchon and his team examine every centimeter of the carbon fiber body in a light tunnel created specially for this purpose. Their procedure as meticulous and painstaking as in an operating theater.
Our quality standard is to see through the eyes of the most demanding customer possible in the most revealing light conditions. That means that all imperfections are immediately visible.
Only after the Bugatti Chiron has passed through this ordeal does it leave the workshop and hit the streets. Once it has made it this far, there is only one thing left to do: step on the gas.
So here we are at the La airfield, and this is the place I can really show you what the car can do.
125 meters per second. That's 1 kilometer every 8 seconds. When driving like this, the Chiron releases enough energy to supply an entire home for a month.
Ready, go.
The official top speed is 420 kilometers an hour. Technical calculations, however, promise something more. Massive amounts of water continually cool the engine when it is at full power.
After racing for 32 years, I have never sat in a car that can accelerate as fast as this one does. And I'm absolutely amazed at the performance. I would not have believed this was possible even 10 years ago.
And that's exactly why Andy Wallace is certain that they will break their own world record with this car. Later in this episode, the most powerful mobile crane in the world. Also, a vehicle that lives up to its name. The Beast displaces more snow than any other groomer. The most powerful engines in the world are not only found on asphalt racing strips. The next ultimate vehicle deploys its power on farmland. The Case IH Steiger 620, the most powerful tractor in the world. With 620 horsepower, it works on the biggest farms in the world. Years of research went into it, with one goal: developing an indestructible machine that can accomplish the most extreme tasks.
When I started, the largest tractor was about 400 horsepower. Now we're at 620.
And this much power is necessary on a modern mega farm.
It's nice to have the big one for this.
But the mega tractor must also withstand long-term stress. The Steiger 620 gets hardly any downtime. The first Steiger 620 was built in 2014, breaking all records. It has a maximum engine power of 500 kilowatts. Thus, it can pull equipment almost as heavy as itself. One place it is used is the Canadian province of Manitoba. One of the most important agricultural regions in the world. Today's job: field work over an area of 2.5 square kilometers, the equivalent of 357 soccer fields. To manage such a heavy workload every day, farmers need a machine with the most powerful modern technology. Oak Nook Farm is one of the biggest grain farms in Manitoba. It produces 15,000 tons of grain per year. Most of the field workers have long since been replaced by technology. Farmer Wayne Dutcherson and his son Justin are preparing the Steiger 620 for today's operation. They can't afford to lose any time. Due to bad weather this spring, they have only an extremely small time window for sowing.
It's been real wet this last fall, and now this spring is shaping up the same way to be real wet. So we have to, when the sun's shining, we gotta get the seed in the ground.
A hard day lies ahead of the farmers. They spend up to 20 hours at a time in their tractors. The reason is the enormous time pressure. The longer they need for sowing, the smaller the harvest will be.
Oh, we'd like to get probably about
600 acres done?
600 acres seeded this unit today.
No, we get more done with this one than the than the last ones we had, and definitely more productive, more power, more efficient, more done in one day.
250 hectares of land await Wayne and Justin Dutcherson. The 620 can do 16 hectares per hour. It pulls a 20-ton sewing machine, one of the widest and heaviest pieces of field equipment. It lets farmers cover a larger area in less time. The 620 has 3 movable joints between front and rear. The 3 connections provide more flexibility and traction than the single large journal bearing other tractors have. The weight of heavy trailers is distributed better. The smaller tractor comes along to the field to move stones out of the way that could impede the sowing. With its 150 horsepower, however, it cannot pull the high-performance farm implement. For that, the 620's maximum power and endurance are necessary.
Just really impressed. Big power it's got, the hydraulic power, and also you can set all your GPS coordinates here to operate it without steering it.
The tractor's advantage: it pulls the biggest implements over the field, but with minimal impact on the soil. Thanks to the tire's huge surface area, the tractor's weight is distributed equally over the ground, thus exerting less pressure. The soil remains loose and well supplied with oxygen. The result, a larger harvest. Justin Dutcherson checks how deep the tires are sinking into the soil.
It's about 1.5 inches. That's very good compaction for this field. Huge tractor, less compaction per square foot, bigger footprint, more power. Yeah, still around a better tractor.
The tracks are only 3.8 centimeters deep, which means less than half as much pressure on the soil as with other tractors. Fargo, North Dakota. This is where the Steiger 620 is built. Much hard work is expended to remain at the forefront of producing the most powerful tractors. Brian Vick is the managing engineer.
Oh, it's awesome. When I started working with Steiger, our largest tractor was 400 horsepower, which at the time I thought was huge. And then we progressed to 500 horsepower, and now we're at 620. And I'm just amazed at the additional power that we've been able to provide.
Steiger has produced high-powered all-wheel tractors since the 1950s. The first models had only 1/5 of today's power. Today, the mighty 12.9-liter engine can produce a maximum of 500 kilowatts of power, the most in its class.
When he gets into a tough spot into the field and needs extra power, this engine will respond with another 40% torque. And that's the power you need to pull through the tough spots.
Such a strong engine produces a lot of heat. The engineers have been tinkering for a long time to develop a suitable cooling system that fits within the tractor's parameters.
One of the biggest challenges we had was cooling the engine. And of course, 620 or 680 horsepower takes a very large radiator. If you look at this tractor, notice the slope of the hood and how low it is in front. That's intentional, gives an operator a very clear view on the front of the vehicle. So one of our constraints was that we would not allow the radiator to grow any taller. We didn't want to restrict operator visibility.
The engineers have managed to put the world's most efficient cooling unit under the hood. This is the only thing that lets huge fields be worked every day with no downtime. In addition, the tractor has the best fuel efficiency. It is also very robust and needs hardly any maintenance. That's important for farmers like Justin and Wayne Dutcherson. For their tractors never stand still for one day. The tractor is also used every now and again in emergency situations. Justin Dutcherson's truck has got stuck in the mud. The fully loaded truck weighs 26 tons, almost as much as the tractor. His father Wayne interrupts the fieldwork to save the truck. No other vehicle can help now.
Oh, I got kind of buried. She's a little bit soft in the yard today. A little bit wet. Yeah, tug her out now though.
With such a heavy load, the tractor activates its turbo mode. It increases its torque by 40%, delivering 500 kilowatts of power.
Give it some tension here and get it out.
Thanks to the torque boost, the rescue mission is child's play.
Yeah, there she comes. It's coming out. Yep.
It's nice to have the big one for this. Yeah, it pulled it right out with no problem.
Yep. Great.
Yeah, it was easy pull.
After 19 hours, the workday draws to a close. The day's goal of 250 hectares has almost been reached.
We had a real good day today. Managed to get lots done. The tractor performed real good and didn't have any other problems, so we got a lot of work done today.
357 soccer fields. It's only possible with the Case IH Steiger 620, the most powerful tractor in the world. Compared to it, even the biggest tractor looks like a toy car. Later in this episode, the biggest dump truck in the world, the monster truck's territory, an open pit mine in Siberia. Good off-road capability and low pressure on the surface. What's important for a tractor also counts for a snow groomer. The next ultimate vehicle grooms the most important slopes in the world. This ultimate vehicle goes by the name of Beast. The Beast is the biggest and most powerful snow groomer ever. It is over 7 meters wide and has 388 kilowatts. Its surface of track area is 17.5 square meters, more than any other groomer in the world. Planai in Schladming, Austria. The Beast's territory. The biggest, steepest and most challenging ski areas on the planet. In a few days, Schladming will host the night race, one of the most difficult World Cup slalom races. Today, the Beast is grooming the piste for this important event. Chief driver Wolfgang Perhab himself is at the controls.
Today is very special. We're preparing for the night race, for the best of the best. The piste should be perfect. So, we're taking care of it today, making it the best we can.
The cable winch prevents the Beast from slipping and thereby damaging the ground below with its weight of 15 tons. Hooked up to its little brother, the Beast starts off. Wolfgang Perhab's first job is to bring the snow back up the mountain that the previous day's skiers have pushed down into the valley.
The important thing is not only to flatten out the piste, but to give it contours. They shouldn't be steep or too angular. They should be harmonious. A challenge, but not a danger to the skier.
Then there's the time pressure. By this evening, the entire piste, 300 meters long and 50 meters wide, must be finished. Track for track, Wolfgang Perhab pushes the snow into position. With just one joystick, he controls all the functions, including the snow blade, the winch, and steering. Thus, he can maneuver the huge snow groomer with only one hand, and at the same time, take care of race preparations. At 7 meters, the groomer is as wide as 5 mid-sized cars. Impressive dimensions, even for a pro like Wolfgang Perhab.
The blade is extra wide, just like the groomer itself. Its great advantage is that it has lots of space for pushing snow.
The Beast can push 8.5 cubic meters of snow at once. Teeth on the underside tear up the snow mantle. The loose snow is then pushed up the blade's convex surface. From there, it falls down in front of the blade, and the process is repeated. This creates a kind of snow cylinder that rolls in front of the blade. The upshot, the snow can be pushed more easily.
My first thought was, it works great. Finally, real horsepower. We used to have 300 horsepower. Now we suddenly have 527. And that's great for a driver. He can fill up the blade and not have to worry about how he'll make it up the hill.
The snow groomer moves up the 52% grade slope at 10 kilometers an hour. The beast is built in Sterzing in South Tyrol. In the 1960s, the engineer and race driver Ernst Prünot developed the world's first ever serially produced snow groomer in a car repair shop. Today, his company is one of the 2 market leaders for groomers. Engineer Martin Kirschmeier was one of the leading minds involved in designing the beast.
Weight is always important to us. We don't want to be too heavy as we've got to drive up the mountain at a high speed. So we had to find a compromise between size, performance, and what could realistically be used on the piste. And that's how we arrived at the beast's dimensions.
In comparison, the world's first serially produced snow groomer looks rather small. In the years that followed, ski areas got bigger and so did the groomers, ultimately resulting in the beast. Its dimensions also pose some challenges for the experienced snow groomers engineers, as Martin Kirschmeier recalls.
The challenge of developing such a large groomer is not only that everything must be larger, but that you have to consider every detail, every small part. Is it still strong enough for the new stresses resulting from the blade's larger size? The vehicle has more power.
To this end, the Beast has a 527 horsepower diesel engine, the kind usually used in cranes and diggers.
When the Beast was started the first time and had its performance tested in the lab and the horsepower was there and we saw that it worked, it was a great feeling for us. We saw, hey, awesome, this is working and we can use this on the snow and we can keep going in this direction.
After a good 3 years of development, the Beast was presented to the public in 2009. It is now used in 75 ski areas. In Schladming, Wolfgang Perhab, the driver, is in the midst of preparations for the upcoming World Cup slalom race.
We're done pushing the snow. Now it's time to start with the detailed work of tilling. It looks good for the best of the best.
His most important tool for this, a tiller 7 meters and 10 centimeters wide.
It has many teeth, and it's important that they are all intact and that we go very slowly and with high rotation speed, so that the tiller really does its job.
This step is extremely important. Only tilling stabilizes the piste. Rotating 1,500 times per minute, the tiller shreds the snow grains. This way, they can melt together to make a stable snow mantle.
The advantage is that this tiller now gives us 7 meters of width, so you don't have to go back and forth as many times on a large area.
2 hours later, as night falls, the job is done. Wolfgang Perhab is satisfied.
The piste is perfect, thanks to the Beast's width and speed.
The night race can begin. Later in this episode, a mine giant. This dump truck can load 450 tons of stones and gravel. Added to its own weight, that's an amazing 810 tons. The next ultimate vehicle reaches its full potential when stationary. Its speciality, the fight against gravity. No other mobile crane can lift such heavy loads to such great heights as the Liebherr LTM 11200 9.1, the strongest mobile crane in the world.
There's nothing better on the market.
It was first introduced at the 2007 Bauma Trade Fair in Munich. Its maximum load capacity is 1,200 tons. The maximum hoist height of this 9-axle vehicle is 188 meters. Germany, the North Sea coast. A new wind farm is being created here on the Butjadingen Peninsula. Wind farms are the chief area of operations for the LTM 11200. For no other mobile crane can lift the incredibly heavy components to a height of 100 meters and more. Today's task, to mount the 62-ton rotor consisting of hub and blades at the top of the wind turbine. Crane operator Marcel Ohler has been driving and operating the XXL crane for a year.
The wind turbine's hub is 108 meters off the ground, and to lift the rotor 108 meters, I have to extend the telescopic boom completely.
This LTM 11200 is equipped with a 52-meter 4-part telescopic boom and a 60-meter luffing jib made of lattice extensions. In different configurations, the telescopic boom can be 100 meters long and the luffing jib 126 meters. Depending on how it is used, the LTM 11200 can be set up in 5,000 different combinations. The so-called Y-guide keeps the crane stable despite the weight of the load and of the boom itself, which can be over 100 tons. The higher the boom and the heavier the load, the more unstable and susceptible to wind the crane becomes. The Y-guide consists of 2 supports affixed to the side of the telescopic boom. Connected to the top of the boom with steel cables, they create counter-tension. Thus, they keep the boom from bending under its own weight and the load attached to it. In addition, they stabilize the crane against crosswinds. The supports swivel and can be adjusted to the boom's incline and load. This Y-guide lets the crane lift 4 times as much weight as it could without. The LTM 11200 is manufactured in Ehingen in southern Germany. It takes about 2 months to assemble the world's biggest mobile crane. Joachim Henkel heads up the statics division and helped to develop the LTM 11200.
The motivation for building an even bigger mobile crane came from developments in wind power. These were so complex that we broke totally new ground. We had never built a 9-axle vehicle. It was an experiment, but we were ultimately successful.
The ground vehicle alone weighs a mighty 108 tons. Since only 12 tons per axle are allowed on the road, 9 axles were the only solution.
Normally, it takes 2 to 3 years to develop a crane like this. Not this size, but with less load capacity. For this one, we needed a bit longer, 3 to 4 years, as it's a bit bigger.
Liebherr presented the new mobile crane for the first time publicly at the 2007 Bauma Trade Fair. Unit price, 5 to 6 million euros. So far, about 65 of these vehicles are in use worldwide. Before a crane leaves the factory, it is extended to its maximum height, inspected thoroughly and tested.
The longer the systems, the more wind sensitive they are, especially when fully extended vertically. This crane must stand firm in every wind situation.
The crane, made of high-strength, fine-grained steel, can work in wind speeds of up to 9 meters per second. The vehicle itself is also tested before delivery. Its drive engine is an 8-cylinder turbo diesel with 680 horsepower. It can accelerate the 20-meter-long vehicle to a speed of 75 kilometers an hour. All 9 axles are steerable, thus allowing the crane to be maneuvered through tight curves despite its long length. The 4 rear axles also have partial automatic steering. The crane thus has a turning radius of only about 15 meters. Meanwhile, at the construction site in northern Germany, preparations are almost complete for lifting the rotor. Having secured the huge blades, workers attach them to the crane's hook block. First, Marcel carefully removes the 62-ton rotor from its mount. The crane is powered by a 367 horsepower 6-cylinder engine. But the rotors, which have a diameter of 82 meters, must first be brought into the upright position in order to be attached above.
The most difficult thing is that the cable operators must precisely see when the rotor is being slowly lifted. The cables must be given tension at the right moment, so the rotor does not move in the wrong direction. At any moment it could hit the guy line, especially on the right side, so the people working the cables really have to pay attention to what direction the rotor is facing as they lift it, so it doesn't hit anything. It's very precise work, and you need a lot of practice. It can be difficult to get it right at the beginning, but the crane can actually be operated with great precision.
While Marcel lifts the rotor, worth several €100,000, slowly to the top, his colleagues on the ground pull and push. Thanks to the way it is appended, the rotor turns upright.
I need to make very sure that I do exactly what the spotter says. As far as the crane is concerned, it's impossible to overload it. It shuts down when it reaches 100% of its load capacity. There's a bit of a safety threshold, so it's not like the crane is about to tip over at 100% capacity or anything. There's a safety threshold, so everything's still fine when it shuts down at 100%.
The crane has another safety feature, an integrated wind gauge that warns the operator about overly strong winds. But today, everything's fine. Meter for meter, the rotor approaches its objective. After about half an hour, the job is finished. The rotor is attached to the top of the wind turbine at a height of 108 meters.
We're always relieved when the rotor is up top and in the hub, or rather in the generator, and fastened. That's always the moment when we can relax.
And as soon as the rotor is fastened, the most powerful mobile crane in the world can move on to the next wind turbine. The last ultimate vehicle also carries heavy loads, and it is itself a heavyweight. It weighs more than a fully loaded Airbus A380. Compared to this ultimate vehicle, even a tractor-trailer looks like a toy. The Bellot 75710 is the world's biggest and heaviest dump truck. Its job, transporting 20 to 30,000 tons of rock per day. It can load over 450 tons and has 2 diesel engines under the hood, with a total of 3,430 kilowatts. Kemerovo in Siberia, the home of Russia's largest coal deposits. The Chernigov's mine runs 24 hours a day, 7 days a week. The 75710 is by far the largest vehicle in the mine. Thanks to its gigantic dimensions, 20 meters long, 10 meters wide, nearly 10 meters high, and a loading space of 270 cubic meters, It has 25% more payload than any other dump truck in the world. Igor Grachev is one of the mine's 4 drivers qualified to operate the giant on wheels. His shift supervisor gives him a new assignment.
I have to do 10,000 tons today, at least 17 or 18 trips.
That means Igor Grachev has to drive about 200 kilometers. A breakdown in the mine would be a catastrophe. That's why every driver checks the truck once a day, including the 8 4-meter-high tires.
One tire costs about 80,000 euros.
Now, time for fuel. A tanker brings it to the dump truck. And even though the tanker itself is nearly 3 meters high and over 10 meters long, it looks positively tiny next to the Bellards. Refueling takes a good 40 minutes.
We refuel once per shift. It's usually enough for 17 to 18 trips. One way is about 4.5 kilometers long. That's a consumption of about 3,500 to 3,700 tons.
Once the tanks are full, Igor Grachev can start. He must climb 24 stairs to reach his workplace, 7 meters off the ground. Despite its size, only one driver operates the dump truck. Cameras help him to keep his surroundings in view. Because of the cold, the XXL truck's engine is always running. The 75710 arrived at the mine in 2014. Even for an experienced driver like Igor Grachev, its size took quite some getting used to.
I started with 110-ton trucks, so between 75 and 110. That's a big difference. Driving this huge truck and dealing with its new dimensions was initially difficult, but you get used to it.
Igor Grachev and the truck descend 150 meters into the mine, where a new coal seam is being opened. This requires removing up to 1 million tons of rubble from the mine. Below, the excavator is waiting to load the humongous dump truck with a mountain of rocks. Thanks to all-wheel drive, 2 differential locks and 2 movable axles, Igor Grachev parks his 20-meter vehicle smoothly next to the excavator. With each scoop, over 40 tons, the weight of an entire tractor-trailer, land in the dumping bed.
The excavator operator monitors the load. But I also have a display in the truck showing me the weight. Here I can see how much has already been loaded onto the truck and how much I'm still able to take.
After 3 minutes and 11 scoops, the Bellards is fully loaded. The excavator operator gives Igor Grachev the sign to drive away. Fully loaded, the Bellards weighs over 800 tons. That it can still match the speed of a normal tractor-trailer is thanks to its unique drive system. For in contrast to other dump trucks, the Bellard 75710 has 2 engines. The power of these two 16-cylinder engines is transmitted via 2 alternators to 4 electric motors, which sit on the axles. In turn, these 1,600 horsepower electric motors drive the wheels. Even when driving fully loaded uphill, like now, the monster truck still reaches a speed of 40 kilometers per hour.
We've arrived at the dumping station. Time to unload.
2 extra strong hydraulic pistons measuring 50 centimeters in diameter and with a working pressure of 250 bars, 100 times more than a car tire, raise the dumping bed. Dumping takes a grand total of only 26 seconds. This trip took Igor Grachev half an hour. He begins the return journey to the pit immediately. To meet his target for the day, he must take away 9,550 more tons. Actually, the Belarusian company Belats built the 75710 purely as a demonstration of their technology. But the mine operators were so excited by the moving giant that it is now produced serially, despite its hefty price tag of 6 million euros. In return, the 75710 can be used all over the world, from 50 degrees Celsius to 50 below. To keep the temperature here in Siberia from freezing the load, a portion of the exhaust is used to heat the dumping bed. The Belats must be serviced every 500 work hours. First, the wheels are checked. Each one by itself weighs 5.3 tons and contains as much steel as 2 compact cars. Automotive engineer Dmitry Urmanov is responsible for the mine fleet's maintenance. The 75710 is something special for him too.
This truck outperforms all others. Its many new features make it more economical. Therefore, we are able to reduce our costs, and it saves us a lot of time. The bigger the vehicle, the better the workflow, because it's possible to transport more goods with it.
As with every other vehicle, the 75710's oil must be checked regularly. One small difference. In this truck, it requires going inside the engine compartment. At 33.5 square meters, it is as big as a whole apartment. The 2 engine blocks are each 3 meters long and 1.5 meters wide.
At first, we were surprised by the engine's size. Then we understood that even though it may look huge from the outside, it is still a normal vehicle. It's just much bigger.
So big that the 75710 is built in a hangar specially designed for that purpose. The XXL dump truck is made of 8 main parts that are then assembled on site in the mines. This is the only way for Belats to deliver the 75710.
We are proud to be the first to actually use such a dump truck. And of course, we're also somewhat proud to be able to do work on it. For us, this is a great opportunity.
The maintenance crew reaches the deck. That's where the control system for the electric motors is located. It is made so that the manufacturer's IT specialists can log in from anywhere in the world to resolve problems.
At the moment, it is the largest dump truck in the world. Models 2 and 3 will be even better and more advanced.
However, there are no plans as yet for an even bigger truck. Right after the maintenance check, Igor Grachev and the 75710 get back to work. Every hour the truck is not being used costs the mine operators several thousand euros. But thanks to his truck's impressive performance, Igor Grachev makes up for lost time and transports the day's assigned 10,000 tons. After 12 hours, Igor Grachev has finished. Shift change.
I'm off now, but I'll be back to work tomorrow morning.
The world's biggest and heaviest mine truck, however, continues working without respite. They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technologically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air. All of them are ultimate vehicles. In this episode, reaching record speeds on giant wheels, the fastest steam locomotive in the world. Of all conventional high-speed trains, it has the most modern drive system, the ICE-4. Also, a luxury hotel on rails. The Japanese Shikishima brings exclusivity to a new level. The mountain climber of trains. This cog railway tackles the world's steepest route. And the longest train in the world. 4 kilometers of cars, cars, and more cars. This ultimate vehicle is a steel monster, the DR18201. Built for high-speed tests, it is by far the fastest steam locomotive in the world. The express locomotive undertook its first journey on May 31st, 1961. Despite its service weight of 172 tons, including tender, it can reach speeds of 180 kilometers an hour. Germany, Sachsen-Anhalt, the former depot in Lutherstadt-Wittenberg, today a railroad museum. And the home of the DR18201. It is over 25 meters long. Its wheels have a diameter of 2.3 meters, making them the biggest on German rails. One wheel set alone weighs 5.5 tons. Tomorrow, the 18201 will undertake a special journey to Poland. In preparation, engineer Matthias Gerhardt must heat up the engine now, a complicated procedure.
Opposed to other steam locomotives which are fired with coal, ours is fired with heavy oil. To make this work, I always need steam from another locomotive or a steam generator to get the engine going, to preheat the boiler, heat up the oil, and finally ignite it.
For this, he uses a so-called steam coupler. This connection brings the steam at a temperature of 200 degrees Celsius from the active engine to the cold 18201. While the engine heats up, the engineer checks the lubricant containers for the wheels and coupling rods. A total of 30 liters of oil is necessary to keep all the chassis bearings and movable parts running smoothly. Now the old lady has been sufficiently preheated. Matthias Gerhardt is ready to put the engine into operation for the first time since its last trip, several weeks ago.
Everything needs to work, but after the locomotive has stood still for a while, sometimes things break. Now is the time when you see if everything is working or not.
Matthias Gerhardt starts the fire in the so-called firebox. It is fitted out with special stones, as heavy oil burns at temperatures of around 1600 degrees Celsius. The petroleum-soaked rag is meant to help start the fire, like using newspaper to light a grill. Now, the moment of suspense. Will Matthias Gerhardt get the locomotive started?
Now I'll move my slide valve to 2 bar of pressure, then I check everything again, and now we'll see what happens.
As soon as the engineer moves the slide valve, the heavy oil is sprayed as a vapor into the firebox and ignited. Matthias Gerhardt looks visibly relieved.
It's working.
The fire heats the water in the boiler under pressure to almost 200 degrees. Only then is the steam produced to power the engine. The 18201's boiler has a diameter of about 2 meters and is easily accessible from the front.
Now we'll check the smoke box. It's obligatory every time after the engine is heated up.
This is where combustion gases and exhaust steam from the cylinders accumulate. Both are discharged through the smokestack. This creates a vacuum that keeps the fire going, assuming everything is airtight.
As we can see, everything's airtight. Nothing will hold up the journey now.
Now the 15,000 liters of water in the boiler have to heat completely, and then the locomotive can drive. "5 a.m. the next morning. Today, 280 passengers plan to travel the 500 kilometers from Leipzig to Poznan, Poland, on the fastest steam locomotive in the world. Together with engineer Peter Weishahn, Matthias Gerhardt will drive the locomotive.
Abfahren!
The 18201 begins moving effortlessly, despite the 500 tons of cars it must pull. In addition to his normal duties driving the train, Matthias Gerhardt must monitor the boiler pressure and keep the fire going.
I regulate the oil supply based on the color of the smoke in order to get the best performance.
A light to medium gray vapor means the fire is burning as it should. Meanwhile, the 18201 has left the train station and can build up speed. At 120 kilometers per hour, Matthias Gerhardt and Peter Weishahn drive the locomotive toward Berlin.
It's a masterstroke of engineering, considering that the driving mechanism, the wheels and axles are from 1939 is just incredible.
With every complete turn of its giant wheels, the locomotive advances 7.22 meters. A great deal of energy is needed to drive the wheels. Thus, the 18201 is designed as a so-called hot steam locomotive. This means that the steam is heated a second time before it goes into the cylinders, thus increasing its energy value. The steam passes through pipes inside the fire tube. There, the heat of the combustion gases doubles the temperature of the steam to about 400 degrees Celsius. Only now is it fed into the 3 cylinders that drive the steam locomotive's wheels. While the 18201 approaches its first stop, Berlin, at a speed of 120 kilometers an hour, the passengers enjoy the journey in old GDR train cars. After 2.5 hours, the train reaches the station in Berlin.
Now we'll take on water, check the bearings, and see how things are.
The locomotive consumed 25,000 liters of water between Leipzig and Berlin. Although every station used to have pumps to refill water, Today, it is only possible at a few stations that have a hydrant, like this one here in Berlin. While the water flows, Matthias Gerhardt and his colleagues check the chassis and refill the oil. For more thorough inspections, the locomotive must come here. The Mining and Steam Locomotive Works, the biggest maintenance and repair center for steam locomotives in Europe. This is also where the 18201 was built in the early 1960s. Udo Steinwasser is a mechanical engineer and an expert on the 18201.
The 18201 was actually developed in order to have a steam locomotive that could go faster than 160 kilometers per hour, in order to test high-speed train cars.
The engineers assembled the 18201 largely out of parts from 3 old steam locomotives. They provided the chassis, the wheel sets and the outer cylinders. Only the boiler was a new construction.
Why was the decision made to use a steam locomotive design? Very simple. Because at that time, steam locomotives made up over 90% of the fleet. A diesel locomotive would have required designing something brand new, and that was deemed too expensive.
The 18201 must go to Meiningen every 3 years for its official inspection. It is disassembled entirely, and all the parts, for example the giant wheels, are thoroughly checked.
The real challenges lie in finding replacement parts, especially spoke wheels and other large elements, or for the boiler. The 18201 is a one-of-a-kind, and today there are no more spare parts for a one-of-a-kind machine of this size.
Thus, spare parts for the locomotive must almost always be made according to the old construction plans. In the meantime, the 18201 has crossed the Polish border and is approaching its destination of Poznan. Even after 10 years, engineer Matthias Gerhardt is thrilled every time he drives this locomotive.
It's like the Mercedes of steam locomotives. There are others that drive just as well, but as I said, I'm fascinated by how smoothly it runs, considering it was designed without the use of computers.
Thanks to its good driving performance, the locomotive continued to be used for regular rail operations far into the 1970s. After a journey of 6 hours, the 18201 reaches its destination. While the passengers go on a sightseeing tour, the engineers will prepare the world's fastest steam locomotive for the return trip to Germany. From a sooty steel monster to an elegant designer train. Later in this episode, the most luxurious train in the world. For passengers, it is like a cruise ship on rails. Our next ultimate vehicle is not the fastest of fast trains, but it has the most modern drive design. The ICE-4. With nearly 13,500 horsepower, it is the most powerful intercity express of all time. With 830 seats, this train is meant to be the new backbone of long-distance rail transport in Germany. The new ICE-4 is almost 350 meters long and has 12 cars. When empty, it weighs 670 tons. Its high speed, 250 kilometers an hour. The home station of this state-of-the-art train, Hamburg, Germany. Maintenance and repair take place here in Hamburg's Eidelstedt district. Mechanics, electronics, digital systems. Everything has been under special observation since trial operations began in October 2016. Fitters like Andreas Friedrich are specially trained to recognize the smallest problems and malfunctions in the new technology.
We're checking the suspension system now and have to look for damage, visible damage on the exterior like flat spots, oily shock absorbers and broken springs. This is the air suspension, which provides greater comfort than the metal springs used in the ICE-1.
Markus Peto works on Deutsche Bahn's flagship train. In the past, his job was called engineer. Today, he refers to himself as a driver. His cockpit is a cluster of computers. Without the most powerful and fastest computing capacity possible, nothing works in this giant of the rails.
This is really special for me. I've worked on the railroad for over 25 years. My father was also an engineer. In 1991, he drove the first ICE from the 401 series. And now, 25 years later, I sat here and drove the first ICE-4 from the new series.
All computers have been booted up.
Let them know we're ready to pull out.
It seems like a space station launch when Markus Peto puts 13,500 horsepower in motion. Despite its power and size, the ICE-4 is about 120 tons lighter than the first ICE series.
It makes you proud when you sit at the controls and perform operations, and you understand how the technology works, how the tractive force is unleashed to make it up the mountains. It's simply awesome.
The ICE-4 contains several independent security mechanisms. They are active during the entire journey and monitor continuously the entire control system.
The systems on board support the driver. They take a lot of pressure off him, making it possible for him to take care of other things, like keeping an eye on the tracks. But in the end, it is me, the driver, who takes action, and the train does what I say.
The passengers are barely aware of the technology. Even in second class, they have comfortable seats and can store more luggage. For the first time, bicycles are also allowed on the ICE. With a reservation, 8 spots are available. Leather in first class, and something special for families in an otherwise no-nonsense environment. The true innovation of the ICE-4 lies underneath the passengers. The drive system. Michael Brom was one of the train's designers.
One of the cars with seats, where we are sitting now, is a locomotive that need not necessarily be at the head or the tail of the train, but rather somewhere in the middle. There are 6 locomotives hidden in this train. They are under the floors of the cars and no one notices them.
6 of the ICE-4's 12 cars are outfitted with 2 so-called rotary drive frames each. Each of these 6 power cars is self-sufficient, being outfitted with the full technology of a locomotive. On the one hand, that means a kind of all-wheel drive. On the other, these locomotive cars can be added to or removed from the train at will. So trains on routes with large altitude differences get more power cars than trains that travel on flat routes. In addition, aluminium is no longer used. Workers are back to bending and welding steel. It's easier to work with. Nevertheless, the body has not become heavier, but rather lighter. The secret lies in the fabrication of especially rigid moldings. The bogies are also 1/3 lighter than on earlier ICEs. It took 10 years for the new train to hit the tracks.
You feel a personal sense of achievement when the things you've long considered, worked on, and discussed in Excel tables and PowerPoint presentations suddenly become tangible, something you can touch, board, and ride. To see it every day and have it become normal for travelers to use.
On a trial run, the ICE-4 travels from Hamburg to Munich and back. The first stop is the terminus station, Hamburg-Altona. Here, driver Markus Peto must walk from one end of the train to the other in order to continue the journey. Backwards, so to speak. This small effort is followed by a reward. Now he is allowed to go full throttle. The ICE's high speed of 250 kilometers an hour is deliberately lower than that of other high-speed trains, to achieve a better energy balance and because it is barely worth it to drive faster in a country as densely populated as Germany. Still, something can always happen. But Marcus Peto is not worried.
The train brakes automatically, so if I get sick, if I pass out, the train would immediately put on an emergency brake. It would stay on until the train stopped. Then the train would stand still while the employees from the back came up to see what was wrong, and then they'd deal with the situation.
By 2023, 119 new ICE4s should be driving on German tracks. The total cost, 5.3 billion euros. It will only be profitable if millions of future travelers also get on board this ultimate vehicle. Later in this episode, a train with unique cogwheel technology, designed to climb the steepest route in the world. From a high-speed train that deliberately forgoes top speed, to a train whose job is no longer to get anywhere fast. The Shikishima, a five-star hotel in a cramped space. The showpiece of the Japanese railway company JR East. Pure luxury for the guests and hard work for the employees. The Shikishima completed its first journey on May 1st, 2017. Its 17 suites have room for a maximum of 34 guests. This exclusivity has its price. Tickets cost between $2,800 and $10,000 US. Tokyo, Japan's capital. The luxury train is waiting to begin its next trip. It took 6 years to build the train. The development costs about $80 million. For the general manager, Michiko Ozawa, it is a milestone in the history of train travel.
In the past, trains were only used to get from one place to another. But the novel concept of this train is to enjoy the ride. It's not about speed anymore, but rather the experience itself. Like on a cruise ship, we also make stops and show the passengers the special features of each region.
Shikishima means 4 seasons. And indeed, the luxury train's routes vary by season. The goal, to always present the most beautiful side of Japan.
The challenge was to assemble the team. The design was developed by Ken Okuyama. Great attention was paid to every detail of the interior design. For example, the wood is a special Japanese wood. The whole team worked very hard. Onboard service was also very important. We have a first-class chef.
The railway company hopes the new luxury train will attract above all rich Japanese retirees, but also wealthy tourists. The Shikishima has 10 cars. 6 of them have sleeper suites for the guests. There is also a lounge with a bar. And a restaurant in which star chefs work their magic. A special highlight, observation cars on both ends of the train. Today, the Shikishima will undertake one of its first test drives. The journey begins at the station in Ueno, a district in central Tokyo. Before the journey begins, the guests can relax in the newly built lounge. A total of 12 service personnel take care of the passengers. Kayo Tamura is one of them. This journey counts as a dress rehearsal for her.
I'm definitely nervous, but this is still only a training exercise, and I'm really looking forward to working on this train.
As the luxury train pulls in, a wave of excitement mounts. Today's guests consist of high-ranking employees of the railway company, journalists and actresses. The Shikishima is already fully booked until March 2018. A lottery decides who gets a ticket. A concierge brings each passenger individually to his or her room. A maximum of 34 guests can travel on the luxury train.
The atmosphere on this train can be compared to no other train. I was fascinated the moment I came on board for the first time. And the service on board is excellent. They make you feel at home.
The 15 standard double rooms all have their own separate bathroom, even including a shower. 11:40, departure. The driver sits at the head of the train, separated from the passengers only by a pane of glass. The Shikishima is powered by an electro-diesel hybrid system, the first in all of Japan. In addition to an electric engine, 2 diesel alternators located in the end cars make it possible to drive on both electrified and non-electrified tracks. The longest route takes passengers all the way to the northern island of Hokkaido and lasts 4 days. In total, 3 different round trips are offered. The goal, to spread tourism to remote regions. While the guests relax, steward Kayo Tamura does an inspection round. In the observation car, the passengers can watch Japan's landscape pass by. That's why the train only travels at a maximum speed of 100 kilometers per hour.
I was excited the first time I boarded the train. It's so luxurious. Every little detail was carefully chosen, every plate designed specially for the train, and everything comes from the regions we drive through. That really thrills me.
It's time to get things ready for dinner. A 5-course meal awaits the passengers in the dining car.
The challenge of my job is that I not only work as a restaurant professional, but I must also be good in every other area, like mixing cocktails or making beds. If you work in a normal hotel, you only have one job. But on this train, I have to do everything, and it's difficult to do everything perfectly.
A rolling 5-star hotel. In the kitchen, a team of 6 people sees to the guests' gastronomic pleasure. The cramped space and the train's constant movements make cooking a true challenge for head chef Iwasaki Hitoshi.
The menu was specially tailored to the conditions here on board. The train moves, and so to keep everything from falling off the plate, I've made a thick sauce. I spread it on the plate and place the food on top.
The dishes and ingredients come from the regions the train travels through on each tour. For train hostess Kayo Tamura, today's journey is only the 2nd time she has worked on the Shikishima.
This is my cheat sheet. I haven't been doing the job for very long, so I wrote down exactly what the dishes are called and what they contain.
In an emergency, she can use a headset to contact her supervisor. While the guests wallow in luxury up above, Kayo Tamura shows us the break room for the service personnel.
There's not much space, and it's very hot and humid. Honestly, it's not that nice to eat here, but we have to do it this way for the customers. It's okay though.
Everything for the good of the guests. After dinner, there is entertainment at the bar. In the meantime, Kayo Tamura takes care of the next task, making up one of the 2 deluxe suites. The young steward makes the beds under the watchful eye of a trainer. For 3 nights in this deluxe room, guests pay about $8,000 US. In addition to a fireplace, the amenities even include a bathtub made of the finest cypress wood.
The customers pay lots of money to travel on this train, so they expect a very high standard of service. I feel like I have to do everything perfectly.
This luxuriousness is outdone only by the next room. A trip in the 2-level suite costs another $1,000 on top.
I've been working here for 3 months, and I want to do my best, satisfy the customers, and make them happy. I can't imagine doing anything else. I really like this job a lot.
After 10 hours, Kayo Tamura's shift comes to an end. And while the guests sleep at night, the luxury train takes them to a new destination, the Shikishima, a peerless vehicle. Just like this iron ore train from South Africa. Later in this episode, the longest train in the world, car after car for more than 4 kilometers. Like the last one, this next ultimate vehicle is known for neither its size nor its speed. Its speciality, ascending a mountain. It is the steepest cog railway in the world, the Pilatus Railway. Thanks to its unique cogwheel system, it handles grades no other train could. The railway was built in 1888. Over its 4.6-kilometer course, it climbs a gradient of up to 48%. Its high speed is 12 kilometers per hour. Its location, the Swiss Alps. The Pilatus rises to a height of over 2,100 meters. The bottom station is in Alpnach, at the foot of the mountain. Christian Müller prepares for a test drive. In 2 days, the railway is scheduled to reopen after the winter break.
We're checking the engines, making sure they don't overheat, and then the 3 brake systems.
The so-called power car is train and locomotive all in one. A locomotive trailed by cars would be too heavy to make it up the extreme grade. There is room for up to 40 passengers in this special cog train. Then Christian Müller starts the 210 horsepower electric engine. An 18-gear transmission transfers the engine's power to the cogwheels. The many gears ensure an optimal transmission on the demanding route. The rails are original to 1888. Before the season opens, they are thoroughly inspected. An arduous task on the steep slope.
The tracks are free. We can go.
Christian Müller always keeps an eye on the tracks.
Driving up, we have to make sure the tracks are free and the overhead wires are clear of branches.
Like the cars, the overhead line is also from 1936, when the railway was electrified.
This is the first 48% grade. This is the first of 3 such sections.
A 48% grade, almost twice as steep as every other stretch of railway in the world. That the Pilatus Railway can drive up even this grade safely and without a problem is thanks to its special cogwheel system. It consists of 2 cogwheels that engage the sides of a rack running between the rails. Safety discs under the cogwheels make sure that the wheels cannot jump out of the rack line. Thus, the train does not lose its grip even at the steepest points and cannot tip over backwards. The car is also specially designed for this demanding route. Much effort was put into keeping the construction light. On a 48% grade, every kilogram counts. After about 15 minutes, the train reaches the halfway station at an altitude of nearly 1,400 meters. The driver, Christian Müller, performs his first inspection. All of the machinery is underneath the car. That makes maintenance easier and creates more space for passengers.
Everything looks good. Temperature's right, not too hot, no wear. Oil, engine, gearbox, it's all good.
The cars were built at the Winterthur Locomotive and Machine Works, meanwhile bought up by Stadler Rail, one of the largest train manufacturers in the world. Urs Wieser worked at the Winterthur Locomotive Works and is responsible for cog railways at Stadler Rail, and thus also for the Pilatus Railway.
The Pilatus in Lucerne, on the other side, Mount Rigi. Getting up there was very attractive for tourism at the time. The Pilatus was much steeper, so something new had to be designed. Cable cars didn't exist yet, so it was an exciting task to build a railway up there.
The Pilatus Railway's first cars were driven by steam. They brought nearly 50,000 passengers a year to the summit, an unexpected success. To increase capacity and meet the heavy demand, the railway was electrified in 1936 for over 1 million Swiss francs. It also received the new power cars, which are still used today. In the first year alone, these cars brought more than 100,000 people up the Pilatus. Even today, the Swiss train manufacturer regularly sells new cog trains. In contrast to the Pilatus Railway, however, they have only 1 cogwheel. The system with 2 cogwheels remained one of a kind, despite its success.
It's an incredible accomplishment. All the things railway engineers invented in the late 19th century. Reckoning by hand, drawing by hand, everything done on paper with a ruler, no resources like we have today. No CAD, no calculation programs, and they had no test tracks. Only when the first train drove did you know if it worked or not.
The engineers who built the Pilatus Railway did everything right. Christian Müller, the driver, has meanwhile almost completed his test drive.
The railway is good. It's 80 years old now, and we're proud it's so dependable. There are few malfunctions or breakdowns. We're proud it runs so well and never lets us down.
Only about 5 minutes until the summit. But then...
Sadly, this is the end of the line. I thought my colleagues had cleared more snow, but there's snow on the tracks ahead. They needed more time than I thought, so we have to go back.
The masses of snow up here at about 2,000 meters are also the reason why the railway only operates in the summer. For the return journey, Christian Müller moves to the second cab. It's there because the car cannot turn around on the tracks. For safety reasons, the train descends at a maximum of only 9 kilometers per hour. If it exceeds this speed, an automatic brake engages and stops the car. An important safety system. Christian Müller tests this brake now to end the test drive.
We stopped moving almost immediately. That's good.
In the next 6 to 7 months, the steepest cog railway in the world will bring more than 500,000 people to the summit of the Pilatus.
From a small lightweight on the mountain to an extremely heavy train that stretches for kilometers.
Six locomotives and 342 cars. The Sichem-Saldanha iron ore train is the longest train in the world.
Being proud of this longest train, couldn't ask for more.
This monster on rails has been operating since December 2007.
It's a monster of a machine.
Its maximum length is 4.2 kilometers. It transports over 34,000 tons of iron ore at a time over a distance of 861 kilometers. Sichem, in the middle of South Africa.
This is the location of one of the world's biggest iron ore mines. Since 1953, over 1 billion tons of ore have been dug out. At the moment, more than 8,000 people work in this mine, 14 kilometers long and 400 meters deep. A single track rail stretches to the port in Saldanha. The trip lasts 18 hours. A problem along the single track line can quickly bring freight traffic to a complete standstill. One locomotive alone is insufficient to pull the 4-kilometer monster. It requires at least 5. The train is so long that it takes 15 minutes to drive by. Freight trains have run on the line from Sichem to Saldanha Bay since 1976. Until 2007, the train's maximum length was 2.3 kilometers. Manager Sadiq van der Skave helped to design the longer trains.
And the main reason for the line was to get the iron ore to the harbor as quick as possible. So we needed to get as much as we can, and that is how we designed the long train.
The trains that leave the mine in Sichem loaded with iron ore have 3 individual sections. Each section typically consists of 1 electric locomotive, 1 diesel locomotive and 114 iron ore cars. All 3 sections are ultimately joined together and then augmented by an additional electric locomotive at the end. At the moment, a train with 4 electric locomotives, 2 diesel locomotives and 342 iron ore cars is being prepared for departure. Responsible for coupling the sections, Christopher Mola-Olwe. He needs 1.5 hours to check all the sections of the train.
1 wagon for coupling, half a wagon coupling. Enclosure now 5 meters for coupling, 3 meters, half a meter.
The challenge: the line to the coast is single track. If only one section of the train stops working, all the traffic comes to a standstill.
One mistake can lead to a very big incident.
The consequence: millions in expenses. The whole train is controlled by the first locomotive. This functions by means of a radio system, RDP, or radio distributed power. The driver sends a signal to accelerate or brake from the lead locomotive to the other locomotives via radio waves, and they send information, for example, about their speed back. If necessary, the lead locomotive is also able to send different commands to the individual locomotives. That means all commands come from the lead locomotive. In addition to the electric locomotives, the diesel ones have meanwhile also been upgraded with a radio system.
What we have done now, we've also installed the DP radio, similar to RDP, to those locos now also, which are giving us a little bit more flexibility.
Since 2016, it has been possible to place diesel locomotives at any point in the train, if necessary, even as the lead locomotive. The primary responsibility lies with driver Paul Brandt Louvre. He alone controls the 4-kilometer-long steel colossus until the midway point. There, he trades places with the driver of the empty returning train and drives it back to the mine. His greatest challenge: he must estimate the energy consumption properly. The fully loaded heavyweight consumes a great deal of electricity.
It's very heavy, so I need to take a little bit more power than the guy on the empty train. Doesn't need much power. He can be in motion at a very low notch or so, and he can still continue. But for me, I need that power in order to get the train, keep it in motion.
He must decide upon the right combination of electric and diesel consumption. In the worst case, the returning train receives no power at all. That means a standstill. The radio waves give him continual feedback. Thus, he has all the information he needs for his estimation.
It's much easier to handle the train. It's much easier to control the train.
Constant monitoring is especially important for a train of this length. If the emergency brake is engaged, the Colossus would only come to a stop after 2 kilometers. But Paul Brandt Louvre loves the challenge.
Said I can't change it for anything in the world. I mean, it's something that I can be proud of, that I am proud of. I mean, being here, and as I said, I'm here for the love of the job.
Only one driver is required to transport 34,000 tons of iron ore in one vehicle across South Africa. They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technologically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air, all of them are ultimate vehicles. The Leopard 2, for many experts the perfect compromise of armor, mobility and firepower. Also in this episode, the most dreaded tank of the Second World War. And the world's safest tank, the Israeli Merkava 4. No other model was produced more frequently, the T-54-55. And finally, one of the most versatile military vehicles in the world, the CV-90. It is considered effective, precise, cutting-edge, and nearly invincible. The Leopard 2, the most legendary battle tank in the world. The Leopard 2 has been in production since 1979. 18 countries around the world count on its strength. Its battle weight is about 63 tons. The primary weapon, a 120mm smoothbore gun. Germany, Augustdorf, home of the German Army's 21st Tank Brigade. The most recent version of the Leopard, the A7, has been used here since 2015. 11 meters long, about 4 meters wide, and 2.5 meters high. It has a 1,500 horsepower engine and is equipped with the latest technology. Today is exam day in Augustdorf. At the live fire area, 20 tank gunner trainees must show what they have learned in the past weeks. So far, the trainees have only shot in a simulator. Today, things get real for Lance Corporal Nicholas and Dirk. Only when both perform well will their training continue.
You're nervous, but also excited. There's been a lot of talking, but now you can take it as it comes.
It's all timed, and I'm a bit worried that I won't see the targets in time, and then won't have enough time to engage. But it should actually be no problem.
Captain Philip is Company Operations Officer and is leading today's exercise. From his command tower, he radios the assignments to the trainees.
In my view, the Leopard is one of the best battle tanks in the world. It's easy to use in all operational modes and phases.
How easy it really is will emerge momentarily. The Leopard 2 has a 4-man crew. The driver sits in front on the right. The loader sits on the left side of the tower. This position is filled today by Lance Corporal Dirk. The gunner sits above the driver and mans the weapons. Today, it's Lance Corporal Nicholas. The commander sits above him. Now, the exercise begins. Thanks to its fluid-cooled 12-cylinder engine with 2 turbochargers and an impressive 47.6-litre displacement, the Leopard 2 can reach speeds of up to 70 kilometers per hour. 60% gradients and 3-meter-wide ditches are no problem for this German-manufactured tank. The exam includes so-called hard targets in the form of old tank wrecks and moving discs. In the tower, Company Operations Officer Captain Philip and his team prepare for the exercise. He gives his orders over the radio.
Bravo, attack. Alpha, surveillance. Position 1-2. Move forward. Over.
The first target, the old tank wreck. They're shooting with practice ammunition. It does not explode upon impact, but emits a bright flash of light.
Fire. Hit. Center. 7 seconds. Hit. Target center.
A direct hit with the very first shot. The trainers are satisfied.
Very good.
The next target, one of the moving discs. As opposed to older models, the 2A7 can also shoot so-called high-explosive ammunition. It does not explode automatically upon impact. Instead, the timing of the explosion can be programmed beforehand. This shot is also a hit.
Bravo, now reverse, go.
The next test, shooting while moving. While moving in reverse, that is. The Leopard can go 31 kilometers an hour like this.
Hit, deep, 9 seconds.
That even inexperienced gunners can hit a target while moving is thanks to the Leopard 2's electronic weapon slaving and stabilization system. The sights through which the gunner aims at the target are mounted on stabilizers that compensate for the tank's movements. Thus, he can keep the target in sight despite the rough terrain. The sights and the laser rangefinder are hooked up to the tank's ballistic computer. This computer combines the information about the sighted target with parameters like the vehicle's own speed and wind speed, thus calculating the weapon's optimal position and adjusting it automatically. Should parts of the system go offline, the Leopard 2 can still shoot. To keep everything functioning perfectly, the tanks must be regularly serviced. The Armored Corps Training Center in Münster. Here, soldiers learn how to operate the 63-ton steel colossus. This is also one of the 52 support locations of the Army Logistics Service provider. The Leopard 2s are regularly checked and serviced in these halls. Sergeant Major Michael Helmrich is the Armed Forces shooting advisor.
The basic idea behind the Leopard 2 was to significantly improve the performance of the Leopard 1.
The Leopard 1 was the first German battle tank after World War II. It was much more agile and faster than the American tanks the armed forces had previously used. In addition, it had a more powerful gun and was the first tank with a weapon stabilization system, which made it possible to shoot while moving.
There were two essential considerations. First, the existing armor had to be strengthened. Second, and more importantly, the fire control system had to be improved.
The origin of the Leopard 2 is a joint tank project from the 1960s between Germany and the United States.
Due to the long development time of about 15 years, including 16 prototypes, it was possible to resolve problems ahead of time that otherwise would have cropped up in normal use.
Since then, the Leopard 2 has been regularly upgraded with new technology. The armor has been continually improved, the weapon system modernized, a stronger cannon added, and numerous new digital systems integrated. Thus, the hull of the current version, the A7, is even better protected against mines and IEDs, and the side armor can be strengthened with additional track skirts depending on the operational area. At the live fire area in Augustdorf, the exam is still in progress.
Bravo, command here. Hard target, double bridge, left.
The gunner trainee, Lance Corporal Nicholas, now has about 15 seconds to find and hit the target.
Tactically, the exam was good. The hits will be evaluated soon.
Today, the trainee shot at a real tank for the first time.
It was really loud. Smelt strange, but was pretty good.
From inside, the gunner doesn't really notice much.
We still want to know whether the two trainees have passed their exam.
Bravo, crew! Assemble! Today's upshot, everyone passed. It was great, indeed better. Good work. Dismissed.
In the next months, the two soldiers will continue their training with the most legendary tank in the world. Later in this episode, the Israeli Merkava 4. It is an exotic tank, departing from the usual basic design. This heavyweight puts especially high value on protecting its crew. World War II was the age of grand tank battles. One of the most dreaded among them, the German Armored Fighting Vehicle 6, known as the Tiger I. It is one of the most legendary tanks of World War II, a steel beast. Dreaded by its enemies, it is unique for its myth of invincibility, the German Tiger I. The Nazis put the tank in the field in the autumn of 1942. Only 1,500 were produced in total. It was dreaded by all on account of its 88mm gun. One specimen is in Great Britain, more precisely in Bovington. This is home to the world's largest tank museum. The collection is unique. Over 300 armored combat vehicles are here. Curator and tank expert David Willey has the overview. For him, it is clear that the Tiger had above all strategic significance for the Germans.
Obviously, there was a fear factor because the tank was so big, so powerful, it could outrange pretty much any Allied tank when it first appears.
The steel colossus is nearly 8.5 meters long, over 3.5 meters wide, and weighs 57 tons. That made it up to 20 tons heavier than all of its opponents on the battlefield. Up to 10 centimeters of steel made the tank nearly impenetrable to enemy fire. When introduced, it was the most powerful tank of its day. With a 700 horsepower V12 engine, the heavyweight could achieve a cross-country speed of 20 kilometers per hour. On paved roads, the Tiger could go twice as fast. But this was reflected in fuel consumption. Every 100 kilometers, the Tiger consumed about 540 liters of fuel. But its built-in weapons technology was also expensive. Many say too expensive. But it is precisely this technology that made the Tiger so special.
So the sighting arrangements, that in combination with that 88mm tremendously powerful gun, you're firing an armor-piercing round which can pretty much go through any known tank when this comes into service late 42, early 43.
The Tiger is a veritable sharpshooter. At a distance of up to 1,500 meters, it could destroy every target. The tank's gun is especially noteworthy. At 4.93 meters, it was the longest of the time, and at 1.6 tons, also the heaviest. Its .88 caliber bore was also unmatched, and with 92 shells on board, the Tiger became a legend on the battlefield, thanks as well to its 10-centimeter thick armor. On paper, the Tiger was superior to all other tanks. But too often the Tiger remained immobile due to technical problems.
And just quite simply, it was put together in a rush. So there was lots of teething troubles, lots of early mistakes, things breaking down. The gearbox it was struggling, the engine to match that 56 tons. It was originally designed for 30 tons. So there's a series of issues they try and iron out during the production run.
The Tiger was its own worst enemy. Technical problems accumulated, and many of the heavyweights simply got stuck in Russia's difficult terrain. One of the tanks survived the war. It is now here in this museum. After months of inactivity, today it is supposed to drive again. If anyone knows every screw, every one of even the smallest of this 70-year-old tank's parts, then it is Mike Hayton.
We've got the only working one in the world, and it's a hard job to keep it in the condition that we like to keep it in. So it's always a challenge to me. All of these grey hairs on my head are due to the Tiger.
Also here today, Mike's team of mechanics. In addition, a fan is here to fulfill a lifelong dream, to drive a real Tiger. But will it start? There is barely room inside the tank for the 5 members of the crew. But Eric Schneider, the tank fan, is overwhelmed.
Oh, it's really nice. It feels a little claustrophobic, but it's nice.
And sometimes the crew had to persevere inside the tank for days and weeks. To get the tank started, Mike first has the 2 heavy battery cells reinstalled. Then he attends to a special feature. This Tiger was deployed in Tunisia before being captured by British troops. To counter the hot and dusty conditions, this Tiger was equipped with a special filter.
It has what they call a FIFO air filtering system, so the system behind me filters the air before it gets to the engine air filters, and every time we lift the deck we have to dismantle it so that we can get access.
Under the hood, a Maybach V12 is slumbering. But the 21-litre engine has its problems. Besides its tremendous fuel consumption, the engine's need for oil required the crew to make sure there were always enough reserves on board. This led to supply problems at the front. Mike checks the fuel level twice, just to make sure.
So we have this much fuel in the tank, so that's enough to run it today.
Now the preparations are complete, and the big moment approaches. The Tiger is going to drive. With every passing minute and every action of his crew, Mike Hayton's nervousness increases.
We try to take every precaution we can, and there's still the unknown. For example, last year we tried to start it for Tank Fest on the inertia starter and it broke. So we had to take the engine out during the winter and repair that.
This could happen today too, of course. Under his direction, the mechanics pull the beast out of the hall. Now, ignition is only a few minutes away.
So, next one, turn the engine over a couple of times. We need the fuel turned on first.
Like an old propeller airplane, the Tiger can also be started mechanically.
Try again.
Only when there is enough oil pressure can the tank be started with the crank.
Wait. Is that full choke? Should have gone by now. Yeah, try again, Darren. Oil pressure okay?
Finally, after months of standing still, the Tiger once again moves under its own power. Admittedly, somewhat hesitantly, but the chains are clattering slowly across the museum grounds. Only a small observation slit lets the driver see anything.
Yeah, change into fourth gear, Darren.
The beast that spread fear and panic on the battlefields of World War II moves forward slowly but surely. The 57 tons of steel creak with every movement, but Mike's meticulous work pays off, and the Tiger finally stands at its new location.
You know, for me it's always very stressful because, you know, we never want to break it, and so we try and do as much as we can to make sure we don't blow up.
The German Tiger 1 in Bovington is the only one that can still drive under its own power after more than 70 years. A true ultimate vehicle. Later in this episode, mass production instead of technical sophistication. The T-54-55 was the standard tank in the Eastern Bloc and became the most produced tank in the world. Since the Second World War, basic tank design has almost always been the same. There are only 2 exceptions, and one of them is our next ultimate vehicle. This tank is considered the safest in the world. The Israeli Army's Merkava Mark IV. Tested in numerous battles, experts rank it as one of the best tanks in the world. The Mark IV variant of the Merkava tank has been in production since 2003. Its combat weight is 65 tons. Its high speed is 64 kilometers an hour. Its primary weapon is a 120mm smoothbore tank gun. Israel, the Golan Heights near the Syrian border. Today, the Israeli army will carry out a large-scale tank combat exercise here. At about 8 meters long, 2.5 meters high, and 3.7 meters wide, the Merkava is one of the largest tanks. And, due to its extremely strong armor, is also one of the heaviest. The rear door provides a safe exit in case of emergency. Its armament packs an extremely powerful punch. A total of 15 tanks are participating in today's exercise. Each Merkava 4 has a 4-man crew: the commander, the gunner, the loader signaller, and the driver. First Lieutenant Menachem Klavan is the commander of this tank. For him and his crew, this exercise is the last part of their training before they're stationed in the border zone.
In this exercise in the Golan Heights, we're playing through various battle scenarios. We train for every possible situation and in every season. We don't know what awaits us when we're deployed. So, we have to train and be prepared for everything.
The soldiers have been at combat readiness for 1 hour. Headquarters could give the command to begin the exercise at any moment. Inside the tank, the soldiers check the systems and electronics again. Each man has his own screen to control and monitor the functions relevant to his job.
The Merkava Mark IV is the best tank in Israel right now, probably the best in the world. When I sit in it, it feels like I'm in my own car. All the safety features give you the feeling that the tank protects you once you're inside.
For defense against guided missiles and armor-piercing shells, the Merkava 4 also has a state-of-the-art electronic defense system called Trophy. A radar with 4 antennas recognizes threats from all sides. Within milliseconds, the system calculates the trajectory, distance, speed, and anticipated impact time of the incoming weapon. Right before the weapon would hit the Merkava, a neutralizing charge is fired that destroys the projectile while it is still in the air. The order has been given to start the exercise. The Merkava 4 has a V12 diesel engine with 1500 horsepower. It drives on continuous track without pads. The track is extremely robust and can even handle rocky terrain without braking easily. At the beginning of the exercise, the tanks take a position on a ridge.
I don't know what's coming next, or what the trainers have prepared. That's part of the exercise, just like on a real battlefield. We're here to practice what it's like not to know what's going to happen.
Using the digital battlefield management system, the commander visualizes the target position on a screen. Now, it's up to the gunner. 7 types of ammunition can be fired from the 120mm tank gun. Its range over 3,000 meters. After attacking from a distance, the tanks advance, using the ridge as cover. Despite its heavy weight, the Merkava 4 can drive up to 64 kilometers an hour. The tank crew's job is now to form the rear guard and provide support for the company. Tel Aviv, Tel HaShomer base. one of Israel's largest military bases. Home to a unit whose mission is to constantly improve tank and vehicle development. One of the engineers is Major R. For security reasons, his real name cannot be used. His task, to make the Merkava, which was developed in the 1970s, even safer and even better.
Back then, it was difficult for Israel to buy tanks from other countries, so we decided to build our own tank in Israel. The basic idea was to build a tank tailor-made for our troops. First, we focus on the men and build a tank around them. The tank's capabilities are adapted to the needs of the troops.
Planning for the Merkava began in the early 1970s. The goal, a tank perfectly designed for the Israeli army's tactics and areas of operation. The first tanks were delivered to units in 1979.
In the 1970s, the biggest challenge was to build a tank with no prior experience. The decision was made to have the various parts made by several Israeli companies.
Based on experience in the field, the Israelis continuously improved the tank. This also goes for the current model, the Mark IV.
Ever since it was first designed 7 years ago, the tank has been upgraded and improved. The idea is to adapt the tank to a system that changes daily.
Studies and initial tests for an even more modern and effective version of the Merkava, the Mark V, have been underway since 2015. Meanwhile, in the Golan Heights, the units have approached to within a half kilometer of their target. The tank crew's job is now to secure the flanks and to provide covering fire for the advancing foot soldiers. The Merkava 4 is perfectly equipped for this too. In addition to its main gun, it has 4 machine guns for engaging short-range targets. To discover threats immediately, 4 cameras are mounted on the Merkava, providing the crew with a panoramic 360-degree view. After a good 2.5 hours, the mission is complete. The target has been taken and surrounded. Commander Menachem Klavan is happy with how the exercise has gone.
It went very well, although it was a challenge. But now, we're ready for every possible scenario.
Undoubtedly thanks in part to the knowledge that they are sitting in the safest tank in the world. Also in this episode, the CV-90 infantry fighting vehicle. It was already considered one of the most modern in the world, but it has now been improved once again for the Norwegian army. The Merkava 4 is used by precisely one country. The next ultimate vehicle was used around the world, from Siberia to southern Africa. For decades, they have been performing their task as the workhorse of armored corps all over the world. Tanks from the T-54, T-55 series. Equipped with the most modern technology of their time, for over 30 years, they were the standard tank for the Soviet Union and their allies, and they are still used in some countries. In total, over 100,000 tanks of this kind were produced between 1946 and 1983. Its combat weight, 40 tons. Its armament, a 100mm gun. Beneckenstein in the Harz Mountains. The T-55's theater of operations in Germany, today only in a museum. The museum has numerous military vehicles and tanks that can be booked for private rides. the biggest star among them, a T-55 from Poland. In Mario Tenzer and Marcel Koenig's tank driving school, this T-55 has found its final calling. For €300, enthusiasts can drive the tank for about half an hour. This once modern tank, however, is slowly showing its age.
It was built in 1972 and needs a lot of maintenance. It's an old lady continually beset by malfunctions.
When the T-55 was chiefly used in the 1960s and 1970s, it was a modern weapon system. In order to buy the tank, however, Mario Tenzer had to remove all its weapons technology. The engine, on the other hand, is still original. Before Mario Tenzer can start the tank, he must preheat it. In order to go easy on the powerful but therefore sensitive engine, it had to be preheated even when it was used in combat conditions.
Of course, it's very special to drive with its 40-litre engine and its enormous power. It's quite a big deal.
Originally, the T-55 had a 4-man crew. Except for the seats for the driver and commander, however, everything has been removed from this model. The T-55 is so robust that even today, 70 years later, it continues to be used in local conflicts, especially in Africa. Mario Tenzer, however, is not very happy with his tank at the moment.
Did you see? It didn't turn. It turns poorly. There's oil everywhere. And it shifts poorly too.
With its unladen weight of 37 tons, the T-55 is a small and agile tank. This is what made it so beloved in its time. It is armed with a 100mm cannon, its rate of fire up to 7 shells per minute, its maximum range 2.5 kilometers. The T-55 is as wide as other tanks of the time, but it is lower and thus makes for a more difficult target. The round, cast tower averts shells better than in earlier tanks. In addition, the T-55 was prized for its simple and robust suspension, unique for a tank, the distance between the first and the second wheel. The idea was to reduce the damage caused by mines and, at the same time, to improve maneuverability. The tank driving school's terrain is no challenge for the T-55. It has a maximum gradability of 60% and can handle lateral slopes of 30%. In addition, it was the first tank to be able to cross waterways up to 4.5 meters deep. After 15 minutes, Mario Tenzer and Marcel Koenig have completed their test drive. But they do not look at all pleased.
During this short test drive, I got 2 blisters just from shifting, since the gears are so unsynchronized. And in one bend, we simply went straight, which means that sometimes we have hydraulic pressure and sometimes we don't.
Inspecting the engine for problems.
Here it's all oily. A somewhat bigger repair job. Oil is shooting out of the side of the engine's fan propeller. You can see it really well here. This part is covered in oil, as you can see on my finger.
Back in the workshop. Under the hood is a feat of engineering, exemplified by the sideways mounted engine. Extremely innovative for the time, It created more space for crew and cargo.
A lot was packed into a small space here. It's very tight. You have to turn 1,000 corners in order to get to a place where you need to make a repair.
The tank's impressive age makes things more difficult. Most of the tanks were built here, at the Chelyabinsk tractor plant, today Uralvagonzavod, one of the world's largest tank manufacturers. Nikolai Molodnyakov is one of the engineers who designed the T-55.
Western countries didn't stop producing tanks after World War II. Hence the great effort here to design a next-generation tank that would set new standards in every way.
The T-55 made its first public appearance in 1958 at the annual Victory Day parade in Moscow. In contrast to its predecessor, the T-54, the T-55 has better armor, a stronger engine, a wider range of fire, infrared aiming, and it was one of the first tanks ever to have an automatic nuclear weapon protection system.
One of the requirements for this tank, and this was the mentality of the time, was that the crew had to be able to repair it right there on the battlefield. The engineers made this possible. And that's why the T-55 is so long-lived and is still being used today.
In the following decades, the T-55 has proven itself in several military conflicts all over the world, among others in Vietnam and Afghanistan. Thanks to its simple basic design, it was very easy to take apart and repair. Only one thing is necessary: strength. Some of the thickly armored plates weigh several hundred kilograms. In Beneckenstein, Mario Tenzer and Marcel Koenig searched for the problem in their malfunctioning T-55, originally built in 1972.
Look there, it's dripping.
A small leak in the hose can bring even the most produced tank in the world to its knees.
It's not so bad. It's not the hydraulic reservoir like we initially thought, but rather the hose behind it. We can see it now that we've taken it apart. It's a piece of cake to repair.
Ultimately, no tank was in use more frequently than the T-54-55. The next ultimate vehicle is also a commercial success. Thanks to its exceptional features, it is already being used in 7 countries. Hardly any combat vehicle is as versatile as this one, the CV-90 Infantry Fighting Vehicle. Equipped with a superb chassis, state-of-the-art systems and powerful weapons, it is the most modern of its kind. Since series production began in 1993, a total of 1,280 vehicles in the CV-90 family have been built. To date, 15 different models of the CV-90 are in use in 7 countries. Setermoen in northern Norway, Setermoen military camp, home of the 1st Battalion. In total, the Norwegian Army has 144 of these infantry fighting vehicles, which differ from CV-90s used in other countries above all with respect to weapons and drive systems. All models of the CV-90 family have the same basic platform, but their final design varies depending on the countries that use them and the locations where they are to be deployed. On today's program in Setermoen, a combat exercise for the CV-90 crews. Company Commander Peter Bakkejord explains the assignment in the briefing.
They've been ordered to do pre-combat checks on their vehicles and their personal equipment. and they will be handed out live ammunition, and then they will head out to the live fire area.
The mission: to drive 5 kilometers in tactical formation to the firing range in the mountains, and there to engage various targets. In addition to the main weapons and the machine gun, the Norwegian CV-90s have a remote-controlled weapon station on the roof, with a thermal camera and a target laser. They also differ from most other tanks in that they drive on rubber tracks. These cause less vibration and are thus gentler on the sensitive technology. Mathias Sorensen has commanded the CV-90 for 2 years.
I like to compare the CV-90 to a multi-tool because it fits pretty much any mission. It has the armor, it has the mobility, it has the weapons like the cannon, the machine gun, the remote weapon system where you are able to mount different weapons, and you have the soldiers in the compartment who can fight along the vehicle. So together we are able to defeat any enemy.
As an infantry fighting vehicle, the CV-90 offers space in the back for 8 infantry soldiers. The middle contains seats for the commander and the gunner, as well as the weapons system. In front are the driver's seat and the engine. Once preparations have been finished, the driver starts the 810 horsepower V12 engine. As an infantry fighting vehicle, the CV-90 brings infantry soldiers to their field location and then supports them in combat. In addition, the 34-ton vehicle has excellent driving features. It can reach a high speed of 70 kilometers an hour and climb slopes with a grade of up to 60%. In the 1990s, Norway became the second country after Sweden to decide to use the CV-90. In 2012, it increased its number of vehicles up to 144. Major Per Rune Hansen is the technical project leader for the CV-90 in the Norwegian military.
All the armored infantry fighting vehicles have more or less the same firepower or the protection, but it was the mobility that was really important for us.
The CV-90 was designed in the 1980s for the Swedish military by the defense contractor Hägglunds, today BAE Systems. The vehicle was supposed to feature high tactical and strategic mobility, to be able to engage a variety of targets and offer large potential for growth.
We had compared with the vehicles that we had in the 90s, the vehicle looked quite the same, but it's a whole new different vehicle. We got rubber tracks on it, which reduces the fatigue on the people in the combat compartment. We got a remote weapon station, and we have an integrated BMS system also, which allows it to be an easier situation for the commander.
And the manufacturer continually develops new systems. One of them, an active suspension based on a Formula One car. Sensors monitor the terrain, as well as the vehicle's speed and acceleration. In milliseconds, the on-board computer uses that information to calculate the optimal counterforce to be provided by the shock absorbers and vibration absorbers, adjusting it automatically. In this way, the vehicle's chassis is raised and kept level. This minimizes the stress on the technology and the crew. Initial test videos show how the system works. For the time being, the new suspension is still in the test phase, but it could be built into all existing models. Meanwhile, the soldiers have arrived at the live fire area. Before shooting, the crews must check all the weapon systems. It is part of the exercise. In order for everything to run smoothly in an emergency, they must consistently train all standard operations.
If we are doing a good job here, we're also more precise when we drive and when we are going to shoot later.
The most important element, the sight. It has an integrated daytime and thermal imaging system, as well as a laser rangefinder.
Now we're making sure that the shooter is on the target. And with this we can see.
The so-called sight checker lets driver Kim Nordanger see whether the sight and the gun are properly synchronized. Today, they are using practice ammunition, called cold ammunition, which does not explode upon impact. Now, the exercise begins. So that everything can be monitored from the inside during a mission, the CV-90 has a digital battle management system. Color screens display all relevant information for the commander, such as a map showing the location of friendly and foreign troops. Since today's exercise is purely focused on target practice, orders are radioed in from the company commander. The CV-90 can fire from a 30mm gun, 7.62mm coax machine gun, or a variety of weapons from the remote weapon station. The crew's final exercise. 3 targets at a distance of about 1,500 meters.
All the rounds are dead on target, center. So they're doing the job right. They've done the small things very good, and that's very important. Do all the procedures correct, and the rounds hit the target.
It is not only the soldiers who have made a good impression during this training exercise. The CV-90 has also once again shown why it is an ultimate vehicle.